they develop network communications and social media platforms, at which point they all decide they have to kill each other.
Okay. Kinda, yeah. Yeah, we're very close. That's good. Aren't you curious that no one mentions that type of solution? Like, there's people who have compiled, there's many Fermi paradox compilations. No one brought something like that up, as far as I know. But oh, you call it?
Uh,
Hmm.
I don't know, but I will say that I think it's pretty obvious that what we're seeing now is that sort of um, that we're coming apart along those axes.
Yes.
So that's my number one thought.
So tell me
Yeah,
what? Okay, why do you think no one mentions it?
good question. I don't know.
I mean,
Um,
it sounds like
mhm.
something that all the, at least the YouTube community that deals with, like Isaac, what's his name, Isaac something, the science and
Isaac Asimov.
no, science and futurism with something Isaac. You don't watch him?
Maybe not.
Yeah, sounds like you don't. Let me pull him up. Like, why wouldn't he talk about it? Like, he's always so positive. So you're not positive about our future. You don't see us going to the stars.
Uh, I'm not. I'm not. Uh, I would say I'm neutral. So I think
Wait a
we've
minute.
got.
Wait a minute. If you're neutral, that means there is a possibility, but you can that's that then that invalidates it as a solution to Fermi's paradox. Fermi's paradox must be mathematical. It must be exactly 100%. You can't have less.
Mm,
You can't say that humanity has a chance against the great filter. That is.
I don't know about that.
What do you mean?
So
Wait. Uh, So if 1 in a trillion, if we have a 1 in a trillion chance, then that civilization of 1 in a trillion should have already conquered the universe. We should have seen it by now.
well,
They should
number
have been.
one,
They should have been
they
here.
could
And yeah, go ahead.
they could. So first off, they don't have to be in the same galaxy or even the same supercluster.
We would see a different galaxy, and they would spread. We would see the spreading. And they would
Yeah,
be
but
here by now.
the universe. So the assumption is that they would build self-replicating probes
They would spread.
that would fly at subluminal
They don't have to
speeds.
build anything. They would just spread. If you
Well,
if
Well,
humanity,
depends. Yeah, it depends a bit on when that civilization comes forth as well.
well, if it's one in
They
a
may
trillion,
come out, come on. They might be much later to develop technology to the stage we are.
so there's another
We don't
you.
know.
There's a Columbia professor that he made a proof, a mathematical proof that there cannot be aliens because they should have been here already. We should have already found
How
them.
so?
What's
So if they were like, let's say, if they were 10 billion light years away from us,
It doesn't matter. Let me
and
find.
that civilization came along, let's say, 4 million years after the Big Bang, we would still wouldn't know because the signals wouldn't have reached us yet.
Right. But no. So you're saying, look, you have to bring it down to like 1 in a trillion, but then you have to so you're saying we have a chance, no one else. So you're saying that so you're saying right now there is a civilization that is spreading. We just didn't notice them yet. You're talking about something astronomically impossible. Let me get you his name and his proof. That's impossible. He said they're either
Why is it impossible? How many planets are there in the universe that might support life?
I don't remember his proof offhand, so it's a perfect mathematical proof. They should be either here or they're not anywhere, and there's no in between, unfortunately. Let me get you the proof. 1 second. His name is like he does moon research.
Did it take time? Yeah.
He does
So
moon.
so
Go ahead. Mhm.
how long after the Big Bang
I understand.
did
I
humans
understand. I understand.
become intelligent?
I understand. He has a great proof. I just don't remember it. I never had to go through it because I didn't think I would ever talk to anyone about this. Let me get you his proof, and then we can discuss it. His name is like Strange Worlds. Strange Worlds channel. Cool Worlds. That's his name. Let me get you his proof.
So you're talking about the Drake equation?
Yeah, of course.
Or which is it?
We're starting from the Drake equation, of course.
Yeah. So the calculation arrives at the estimated figure of 100 million worlds where life has been forged by evolution.
No. Hold on. I'll give you the proof in the side chat of this VC. If you want, you can play it and we can listen together. You can play on 2x and we can discuss it.
There are many proposed solutions to the Fermi paradox, aka where are all the aliens? In 2021, a new one was published that has gained a lot of attention, the so-called Grabby aliens hypothesis. Today, I'm going to explain what this theory proposes and ultimately why I
posted,
don't
you
buy
said?
it.
Side chat of this VC.
Interestingly, Grabby aliens is the brainchild of an economist, not an astronomer. That's Robin Hanson. The basic idea is that the development of intelligent life is very rare in the cosmos, but in some small fraction of cases, the aliens become Grabby. Okay, so what is Grabby? It's simply a species that inexorably expands through space and changes stuff in a fairly obvious way. Hansen leans on his economics background here and argues that transforming the environment is a defining quality of human civilization, and thus by extension, aliens too. Grabby aliens are, by definition, loud, obvious, and if they were out there...
On the side chat of this VC, in the VC we're in, did I get it right? Yeah, on the VC, it's in the side chat. It's a link, Grabby, starts with do Grabby aliens solve the Fermi paradox. Do you see it?
No, it doesn't show up on my phone. I don't know why.
In this VC, there is a side chat, not the general chat. In this VC, there is a side chat. Like no one knows, but in this VC, there is a side chat. Every VC has, you know what a VC is?
Yeah.
So there's a side chat. You see where it says general minus VC, there is an open chat bubble.
Yeah.
Click that.
Yep.
And then you'll see on your right side, the bottom, cool worlds, do Grabby aliens solve the Fermi paradox?
No, I don't. It doesn't show up. I don't know why.
What do you, wait, are you on the phone?
Yeah.
Oh, okay. Do you want me to put it in the general chat? Would you see?
Put it in the general chat.
All right, there you go. It's in the general chat. So you can't share and I can't share. Omnivore, do you want to share it so we can play together?
Grabby aliens?
Yeah. I mean, Grabby aliens is a famous postulate or whatever, famous hypothesis. He's an economist that invented the Grabby aliens theory.
By who?
Grabby aliens?
There are many.
Yeah, but who's the scientist you're talking about?
Who's Grabby aliens, or who is the scientist?
No, you said you had it from some sort of scientist.
Cool worlds. Cool world.
Yeah, I'm looking at the video. Just give me quickly through it.
Okay, so let's I'll listen to it again and then we can discuss it.
The Fermi paradox, aka where are all the aliens? In 2021, a new one was published that has gains on his economics background here and argues in the cosmos, but in some small fraction of cases, the aliens become grabby. Okay, so what is grabby? It's simply a species that inexorably expands through space and changes stuff in a fairly obvious way. Hansen leans on his economics background here and argues that transforming the environment is a defining quality of human civilization, and thus by extension, aliens too. Grabby aliens are, by definition, loud and obvious, and if they were out there, we'd see entire regions of the sky that were in some way noticeably different from the rest of the universe. A key feature of the model is that the emergence of intelligent life is very rare, and in fact, humanity can be understood to be the product of a series of improbable evolutionary transitions known as the hard steps model. This hard steps hypothesis is a whole other beast popularized by the cosmologist Brandon Carter. In a seminal paper from 2007, Carter imagined a series of doors with hard locks that someone is forced to pick in a fixed interval of time. Now, if the average time to pick each lock is longer than the available window, a so-called hard lock, then it's very unlikely they'll get through even the first door, let alone a series of them. But like monkeys on a typewriter, given enough instantiations, someone will get lucky and pick through all of the doors in the allotted time. It turns out that even if these locks have wildly different difficulty levels, the people who do luckily break through the series of them will look back and find that it took them about the same amount of time to break through each of those doors. So now Carter applies this idea to biological evolution. He argues that there were a series of transitions that were necessary to get to us, but they would all appear roughly uniformly spaced in time if they were all hard steps. Yet more, the time left on the clock would roughly equal the total available time divided by the number of hard steps. So given that the Earth has a total habitable window of 5.4 billion years, but only has about 0.9 billion years left, this yields 6 hard steps, give or take a few. So to come back to grabby aliens, the fact that these transitions are hard means that barely anyone should be around the universe after just 14 billion years, the present age of the cosmos. The current population is thus just the lucky few lockpickers that happen to break through, which includes us. But here's the thing. Some other Earths out there, but not us, could last for trillions of years, and for them, success is not a matter of if, but when using this model. Even if the steps take 100 billion years each, they have the patience to wait it out. The idea of planets lasting this long is not so crazy. After all, the most common type of star in the universe is an M-dwarf, and those indeed last for trillions of years. So this creates a dilemma. Most sentient, conscious beings should be born hundreds of billions, if not trillions of years from now. The fact that we live so early in the history of the cosmos presents somewhat of a mystery. Hansen argues that the solution to this problem is to put a deadline on the available window for civilizations to emerge. New civilizations simply cannot emerge a trillion years from now because something about the universe fundamentally prohibits that. And to Hansen, that something is grabby aliens. These species expand out and gobble up all of the habitable real estate, leading to a permanent phase change that prevents species like us from ever emerging again. So that's the basics of the model. But when trying to estimate the various parameters of it, such as the expansion speed and emergence rate, Hansen and colleagues have to contend with a fairly obvious piece of evidence that flies in the face of this theory. We don't see any grabby aliens out there. And remember, by definition, grabby aliens are obvious and easily detectable. To get around this, they invoke the clever trick of setting the speed of expansion to be very fast, in fact, approaching the speed of light. Since we can only receive information from distant parts of the cosmos at the speed of light, then we have no way of detecting such grabby aliens until they basically appear. The final model ends up predicting that some 40 to 50% of the universe is currently occupied by grabby aliens, and that this expansion wave is growing, filling in the remaining holes as it goes. We'll encounter this wave of colonization in about 1 billion years' time, and Hansen predicts a 1 in 10,000 chance that we will ourselves become such a grabby civilization before that time. So that's the idea, and it has caught on. PBS FaceTime, Kurzgesagt, and many others have made videos describing this idea, which have amassed tens of millions of views. Hansen himself has discussed the idea on Lex Fridman's podcast, and I think you would be forgiven at this point for assuming that the idea has become widely accepted and almost canonical at this point. You know, I don't usually make videos weighing in on other people's theories, but many of you have asked for my opinion on this, and I haven't seen any pushback out there, so I am going to offer a counterweight. But before I do, let me first just say that I think this idea is very clever, thought-provoking, and I hold Hansen's work in high regard. Out of respect, I sent my criticisms to Hansen ahead of making this video, and we even chatted about it together cordially. What I hope my criticism does here is provide an opposing position, so you can ultimately make up your own mind about this provocative idea. With that in mind, let's get into my criticisms. Before I do, I just want to take a moment to thank the sponsor of today's video, and that is Image Tips. Thanks to access to their huge, clicking that link through these together. Criticism number 1, do check them out. Now back to the video. Okay, when it comes to grabby aliens, I have 3 major criticisms, so let's walk through these together. Criticism number 1, the hard steps model. Grabby aliens is predicated upon the hard steps model, which we don't know to be true. It may very well be that the development of intelligent life is in fact very easy. It just takes a few billion years to play out. A remarkable feature of evolution is the continual growth in biological complexity, a property that assembly theory argues could even be used.
I think it's the wrong video that I wanted to show you. I mean, you can watch it. We can discuss grabby aliens, but I don't know if that's the one I wanted. He has an actual proof, but I don't see. Where is it? Maybe this one.
To suggest aliens are out there or interpret ambiguous signal and move. Aliens, every science channel's favorite topic of discussion. Let's face it, it's a standard move in the clickbait playbook to suggest aliens are out there or interpret ambiguous signals as evidence for aliens. I'm sure you see stuff like this. The most ridiculous examples typically feature Michio Kaku's face and some outrageous headline. So clearly, I'm making a huge YouTube mistake by making a video which goes the other way, but for the last few years, I've become increasingly concerned about the problem I'll discuss with you today. This is an idea which myself and Grant Lewis, who you might have seen in very past videos, have finally put together into a new submitted research paper, which I'll link to down below in the description. And by the way, this research was supported by many of you, our viewers, supporters to the Cool Worlds Lab research program, which starts from as little as the cost of a coffee once per month. Okay, let's start with a thought experiment. One first posed in 1968 by legendary physicist and statistician Edwin James. Imagine that you approach a table covered by many flasks of...
Yes, this is the one. You can watch that, but this is the one. This is the mathematical proof that there are no aliens, that it's impossible. And we're hopeless. We're doomed. So I pasted it in the general chat. You can watch it after.
Of water. The volume of water in each is about the same, but of course small variations exist. Likewise, the room is pretty much the same temperature and pressure at all locations, but slight variations naturally exist here too. Next, I hand you a random chemical, let's call it compound X, and I ask you the following question. In what percentage of these flasks of water will compound X dissolve? Give me your best guess. Now, if you have no prior information, James argued that one might reasonably guess either 0% or 100%. Or numbers very close to that, like 1% and 99%, to account for the slight differences between the water. However, James argued that it would be very unintuitive to guess a number of around 50%, because if it was 50%, then it would imply that the small differences from flask to flask were sufficient to tip the solubility either way. And
So
post
what
that
was
prior information, variations in each legendary physicist lab research program, which is Edwin James. Imagine that you approach a table covered by many flasks of water. The volume of water in each is about the same, but of course small variations exist. Likewise, the room is pretty much the same temperature and pressure at all locations, but slight variations naturally exist here too. Next, I hand you a random chemical, let's call it compound X, and I ask you the following question. In what percentage of these flasks of water will compound X dissolve? Give me your best guess. Now, if you have no prior information, James argued that one might reasonably guess either 0% or 100%.
Yes.
Or numbers very close to that, like 1% and 99%, to account for the slight differences between the water. However, James argued that it would be very unintuitive to guess a number of around 50%, because if it was 50%, then it would imply that the small differences from flask to flask were sufficient to tip the solubility either way. In other words, if this was true, then the conditions in the room would have to be almost perfectly set to the threshold point between dissolving and not dissolving, balanced on a knife edge. Unless someone is playing a cruel trick on you, such fine-tuning would be surprising, and thus James concluded that the probability chart should look something like this: a high probability of 0% and equally so for 100%, but crucially, a valley of improbability between them. This thought experiment provides some conceptual understanding, but James went far further than this and rigorously proved that this must be true, and he's now credited as one of the founders of what we now call objective Bayesianism in modern statistics. Now, James never really thought about applying this to astrobiology, but for me, ever since I heard about this thought experiment, the connection was obvious. But instead of those flasks of water, we would now have possible seats for life, like star systems. And instead of asking whether compound X dissolves or not, we instead ask whether intelligent life eventually develops or not. When we look out at the stars in the sky, we wonder what percentage of them could have intelligent life. James already seems to provide us the answer. It is likely a number either hovering around 0% or nearly 100%. To quote Arthur C. Clarke, both are equally terrifying. Now, a basic question that one might have at this point is, how does this all square with the famous Drake equation, which defines the number of communicative intelligences in the galaxy, n, as a product of 7 input variables? I know, before you comment, many of you hate the Drake equation. Trust me, I hear you. But I think it's become popular to dunk on the Drake equation without actually paying attention to what Drake said. The real reason why the Drake equation's reputation has been dragged through the dirt is because it is an equation which has been misused and frankly even abused. You're not supposed to guess random values, plug them in, and then write a new paper proclaiming that there are 42 civilizations in the galaxy. It's too long of a topic to get into today, but fortunately, I have made a double-parted video all about this up here. So if we can accept for the moment that in principle, a Drake-like equation should be possible, then it seems in tension with James's perspective, who argued for a kind of all or nothing type scenario. A ninja move in our new paper is that we prove that the two perspectives can be unified by adding in a new element into the Drake equation, which frankly should have been added in long ago for it to make any sense. As it stands, the Drake equation is essentially unbounded. Yes, we have some constraints on a few of the terms, but that's not really what I mean. What I mean is that even prior to having any constraints on these terms, one can make the Drake equation predict arbitrarily large numbers of civilizations out there. As an example, let's set all the fraction terms to 1, civilization lifetime to 10 billion years, and the star formation rate to say 100 stars per year. Congratulations, you now have 1 trillion stars in the Milky Way that have civilizations around them. The problem is that there aren't 1 trillion stars in the galaxy to begin with. This is why the canonical framing of the Drake equation makes no sense. There are many of the problems with the Drake equation too. Like here we have 7 input variables, but why should it be 7? We could easily extend that to far larger numbers. Someone might reasonably say that we should add a fraction for how often multicellular life develops as a critical step. And someone else might argue that we need language development as another critical step, and so on and so on. For years, I've argued that we should just do away with this specific formulation and instead strip it down to the simplest form we can, what I call the birth-death formalism. In any volume, be it a galaxy or a supercluster, the number of civilizations present must be a balance of birth and death. Some number of civilizations are emerging each year, and some are dying. Drake's original equation is an overly elaborate version of this idea, with the first 6 terms in fact representing the birth rate, and the last term being the reciprocal death rate. In my opinion, it is all of these extra details that cause the problems and criticisms often levied at the Drake equation. Far better just to boil it down to the process of birth and death. After some settling time, we should expect the galactic population to reach an equilibrium point, for which the number of births per year equals the number of deaths per year. Balance.
Perfectly balanced, as all things should be.
The total number of births per unit time must simply be the birth rate per location multiplied by the number of unoccupied stars, which is the number of total stars minus those already occupied. Similarly, the number of deaths per unit time is the average death rate per location multiplied by the number of occupied stars. Equating these two is the balance point, a steady state condition. Rearranging this a little, we can write that the fraction of stars which are occupied must equal this. In fact, for notational convenience, let's call this F, the occupation fraction. This term on the right, lambda BD, the birth to death rate ratio. Now, so far, all we have assumed is that the galactic population is in a steady state. That is to say, it is not going through a dramatic episode of population explosion or decline. Also, I've been referring to stars a lot here, but you can switch it out for planets or even cubic light years if you prefer. The equation still holds. Finally, we are being agnostic about the mechanism of birth and deaths here. Births could be spontaneous or they could be through empire building. Likewise, deaths could be due to internal forces or external ones. In any case, the equation still holds. So let's make a graph of this F term, the fraction of stars which are occupied by intelligent civilization. Starting over here, when the birth to death rate ratio is tiny, there are hardly any births, and anyone who does get born dies pretty quickly. As a result, the galaxy is nearly empty. As we dial this ratio up, though, we get more and more civilizations. Eventually, increasing the birth to death rate ratio any higher has diminishing returns. By this point, nearly the entire galaxy is already occupied. There's just not much benefit in pumping it up any further. If the shape of this curve looks familiar to you, it should. This S-shaped curve appears in the real world all the time, including ecological systems, a fact known since at least the 19th century. For example, if you let mold grow on a piece of bread, we start out with very little mold and then we see it spread rapidly before finally getting to a state where growth stalls because there's basically no bread left anymore. Like civilizations in the galaxy, we can't have more mold than there is substrate. Another example is tech adoption. So you have your early adopters buying that first generation iPhone, and then the mainstream gets in on it before eventually growth stalls because now everyone has an iPhone and Apple have approached a ceiling in sales. The birth-death formalism solves the issue of Drake's original equation being unbounded, as well as littered with arbitrary and poorly defined terms. Great, but how does this connect back to James, to his all-or-nothing conclusion? Well, it's apparent from looking again at this curve. Previously, I said the minimum and maximum x-axis values to be 10 to the minus 3 and 10 to the positive 3. But truthfully, the numbers could be much, much more extreme than this. Let's extend the axes out to account for our ignorance here. In doing so, the neck of the S-curve gets narrower and narrower. In this picture, there is a huge range of parameter space where the galaxy is nearly empty, and there is a huge range of parameter space where the galaxy is nearly full, but only a tiny, tiny sliver of parameter space where we have intermediate values. In other words, this is finely tuned. This is the connection we've been looking for back to James. In fact, in our paper, we formally prove this. If we adopt a log uniform prior for lambda BD, which is the typical uninformative prior for a scale parameter like this, then we in fact prove that F follows James's original distribution. We get all the way back to his result. So there's something profound here. Not only have we connected the viewpoints of Drake and James together, but we have revealed that the conclusion is the same for both. The galaxy is either teeming with intelligent civilizations or it's nearly devoid of them. But something in between is highly contrived. This conclusion poses a challenge for those seeking the signatures of technological civilizations out there, because let's face it, it seems pretty unrealistic that nearly every single star has a technological civilization around it. After decades of listening for radio signatures, we only hear silence. We don't see engineered stars littered across space or laser beams sweeping the sky. Indeed, we don't see anything out there that cannot be explained by natural law. If the occupation fraction really was close to 100%, then I think we'd really have to do some mental gymnastics here to make sense of how astronomers just seem to see a lonely empty galaxy. Yet more, even Earth's history proves this is contrived, since technology has only been around for a tiny fraction of its entire lifetime. So if we dismiss the high occupation scenario, then there's really only two options left. One is that the answer is somewhere on the neck of that S-curve, or equivalently in James's valley of improbability. Or two, the answer is somewhere in the quasi-plateau of a desolate galaxy, which objectively is a far more likely outcome. Hence the title of this video and also our paper, where really what we're saying is that anyone hoping to assess an alien signal is implicitly betting that the improbable valley is somehow probable against all of the odds. When I came to this conclusion, I felt torn, even a little distressed, because for me, the search for extraterrestrial intelligence is one of the most exciting and special endeavors out there. I grew up dreaming of searching for alien life. So let's just be clear, I have zero desire or intent to tell you that it is a waste of resources. But at the same time, that naively seems to be what our results imply. So I have, of course, been desperately trying to rip apart my own paper and try to find some way out of this, which, by the way, is actually good practice anytime you write a scientific paper. There's a couple of escape routes we could try here, two cards we might pull to try and wriggle our way out of this box. The first is that we may indeed be on this plateau of a mostly lonely galaxy, but that's okay, because the plateau doesn't say that nobody is out there, it just says that very few are. So to overcome it, all we need to do is dial up our survey size. One SETI surveys typically cover about 10,000 stars or so, but of course there's another 100 billion to go just in our own galaxy. Perhaps then we just need to up the ante and we will hit success. Mathematically, success requires lambda BD is some number greater than the reciprocal of the number of stars in our sample, but at the same time, it must be less than roughly 1, else we'd approach the filled galaxy scenario that we've already discounted. The problem is that even if our sample was the entire galaxy, some 10 to the 11 stars, there's no obvious lower limit on just how ridiculously small lambda BD could be. There's no useful theory of civilization birth and death rates. As an example, let's say the true value was 10 to the power minus 30. In that case, even after surveying the entire galaxy, the probability of finding another civilization would be 10 to the power minus 19, an unthinkably fringe outcome. And here's the kicker. There is absolutely no reason why lambda BD could not indeed be 10 to the power minus 30, or indeed a value far, far smaller. Now, yes, one can have a personal preference for a higher value, but critically, one cannot justify that from an evidential position.
What is faith? It is belief in the absence of evidence. Now, I don't propose to tell anybody what to believe, but for me, believing when there's no compelling evidence is a mistake. The idea is to withhold belief until there is compelling evidence.
Perhaps a more promising avenue is to violate the fundamental assumption of our work, that the population of the galaxy exists in a steady state of birth-death balance. Remember, that's basically the only assumption we make. Now, if this were true, then either the population would be in a state of decline, or alternatively, an ascent. A decline seems immediately improbable. There is nothing about the universe which is making it less hospitable over time. In fact, really quite the opposite. If anything, the early universe was a far more hostile place, littered with gamma ray bursts, supernovae, and rapid star formation phases. A population, in a sense, seems more plausible. Perhaps a galactic empire is in ascendance, and thus engineering lambda B upwards over time through some colonization programs. This is perfectly possible, and I know there are many persuasive proponents of this idea, but for me, this actually introduces another fine-tuning problem. To see this, consider that even traveling at the speed of our existing space probes, it should be possible to colonize the entire galaxy in a much briefer time span than the galaxy's current age. When sped up over cosmic timescales, colonization waves look like almost immediate phase transitions. They happen very quickly. So 3 options exist. Either we live before this colonizing civilization ever emerged, in which case there's no one to talk to, or we live during the expansion phase, which is an incredibly brief episode in cosmic history, remember, or we live post-colonization phase, which contradicts our observations of the galaxy. So despite my best efforts, I personally can't find a way out of the pessimism our paper implies. Despite all of this, there are 2 reasons why we should keep searching for alien life. First, the potential return. Yes, the probability might be small, but the ROI could be incalculable. The greatest discovery in all of science. If we give up and we stop searching, then we guarantee not detecting anything. And second, perhaps we really are in the filled galaxy scenario after all, something I discarded as incompatible with observations earlier. So how can that be? Well, so far I've been talking exclusively about technological civilizations, which indeed seem to be ostensibly rare, but I certainly cannot discard the idea of simple life being around nearly every star in the universe. The truth is that we have no observational constraints about it at all, and ubiquitous life is consistent with Earth's history and geography. And who knows, maybe they do go on to develop technology very often too. It's just that it looks nothing like anything we can even really imagine. So when we look out and see an apparently empty galaxy, perhaps it's just because we can't see the forest for the trees. We're not looking in the right way. If so, we need to diversify our methods, not just aim to increase our sample size ad infinitum. My thinking on this topic has been evolving over the last few years, as you have seen right here in real time on this channel, and I'm sure it will continue to do so in the future as well. But you know what? That is how science works. We iterate, we don't stagnate. I think that James's perspective is a very valuable way to approach this problem. We sometimes forget the wisdom from the past. Hopefully, this starts new discussions on how to proceed going forward. For me, this is always such a fascinating topic to wrestle with that I'm sure I'll be pondering these questions until my final days. As creatures of curiosity, we can't help it. Like an insatiable itch that we're drawn back to over and over again in the hope that one day we might finally crack it. So until next time, stay thoughtful and stay curious.
Did you finish? Hey, Omnivore. I can't hear you. I can see you're saying something, but I can't hear you. Maybe you're not saying anything. Omnivore.
So that was a good video. I just finished it.
Which one?
The one about grabby aliens
Okay.
or lack thereof.
And what about the second one? Did you see the second one that I sent?
No, I haven't. Hold on.
So I'll put it, oops, in the side chat because I already put it in the other one, I think. It's called Crowded or Lonely.
Okay.
I think Crowded or Lonely is better. Did you understand the Grabby aliens hypothesis?
There are many proposed.
Okay, let's listen to the Grabby aliens.
Proposed solutions to the Fermi paradox, aka where. There are many proposed solutions to the Fermi paradox, aka where are all the aliens? In 2021, a new one was published that has gained a lot of attention, the so-called Grabby aliens hypothesis. Today, I'm going to explain what this theory proposes and ultimately why I don't buy it. Interestingly, Grabby aliens is the brainchild of an economist, not an astronomer. That's Robin Hanson. The basic idea is that the development of intelligent life is very rare in the cosmos, but in some small fraction of cases, the aliens become grabby. Okay, so what is grabby? It's simply a species that inexorably expands through space and changes stuff in a fairly obvious way. Hansen leans on his economics background here and argues that transforming the environment is a defining quality of human civilization, and thus by extension, aliens too. Grabby aliens are, by definition, loud and obvious, and if they were out there, we'd see entire regions of the sky that were in some way noticeably different from the rest of the universe. A key feature of the model is that the emergence of intelligent life is very rare, and in fact, humanity can be understood to be the product of a series of improbable evolutionary transitions known as the hard steps model. This hard steps hypothesis is a whole other beast, popularized by the cosmologist Brandon Carter. In a seminal paper from 2007, Carter imagined a series of doors with hard locks that someone is forced to pick in a fixed interval of time. Now, if the average time to pick each lock is longer than the available window, a so-called hard lock, then it's very unlikely they'll get through even the first door, let alone a series of them. But like monkeys on a typewriter, given enough instantiations, someone will get lucky and pick through all of the doors in the allotted time. It turns out that even if these locks have wildly different difficulty levels, the people who do luckily break through the series of them will look back and find that it took them about the same amount of time to break through each of those doors. So now Carter applies this idea to biological evolution. He argues that there were a series of transitions that were necessary to get to us, but they would all appear roughly uniformly spaced in time if they were all hard steps. Yet more, the time left on the clock would roughly equal the total available time divided by the number of hard steps. So given that the Earth has a total habitable window of 5.4 billion years, but only has about 0.9 billion years left, this yields 6 hard steps, give or take a few. So to come back to Grabby aliens, The fact that these transitions are hard means that barely anyone should be around the universe after just 14 billion years, the present age of the cosmos. The current population is thus just the lucky few lockpickers that happen to break through, which includes us. But here's the thing. Some other Earths out there, but not us, could last for trillions of years, and for them, success is not a matter of if, but when using this model. Even if the steps take 100 billion years each, they have the patience to wait it out. The idea of planets lasting this long is not so crazy. After all, the most common type of star in the universe is an M dwarf, and those indeed last for trillions of years. So this creates a dilemma. Most sentient, conscious beings should be born hundreds of billions, if not trillions of years from now. The fact that we lived so early in the history of the cosmos presents somewhat of a mystery. Hansen argues that the solution to this problem is to put a deadline on the available window for civilizations to emerge. New civilizations simply cannot emerge a trillion years from now because something about the universe fundamentally prohibits that. And to Hansen, that something is Grabby aliens. These species expand out and gobble up all of the habitable real estate, leading to a permanent phase change that prevents species like us from ever emerging again. So that's the basics of the model. But when trying to estimate the various parameters of it, such as the expansion speed and emergence rate, Hansen and colleagues have to contend with a fairly obvious piece of evidence that flies in the face of this theory. We don't see any Grabby aliens out there. And remember, by definition, Grabby aliens are obvious and easily detectable. To get around this, they invoke the clever trick of setting the speed of expansion to be very fast, in fact, approaching the speed of light. Since we can only receive information from distant parts of the cosmos at the speed of light, then we have no way of detecting such Grabby aliens until they were basically here. The final model ends up predicting that some 40 to 50% of the universe is currently occupied by Grabby aliens, and that this expansion wave is growing, filling in the remaining holes as it goes. We'll encounter this wave of colonization in about 1 billion years' time, and Hansen predicts a 1 in 10,000 chance that we will ourselves become such a Grabby civilization before that time. So that's the idea, and it is caught on. PBS Spacetime, Kurzgesagt, and many others have made videos describing this idea, which have amassed tens of millions of views. Hansen himself has discussed the idea on Lex Fridman's podcast, and I think he would be forgiven at this point for assuming that the idea has become widely accepted and almost canonical at this point. You know, I don't usually make videos weighing in on other people's theories, but many of you have asked for my opinion on this, and I haven't seen any pushback out there, so I am going to offer a counterweight. But before I do, let me first just say that I think this idea is very clever, thought-provoking, and I hold Hansen's work in high regard. Out of respect, I sent my criticisms to Hansen ahead of making this video, and we even chatted about it together cordially. What I hope my criticism does here is provide an opposing position, so you can ultimately make up your own mind about this provocative idea. With that in mind, let's get into my criticisms. Before I do, I just want to take a moment to thank the sponsor of today's video, and that is Storyblocks. One of the most challenging parts of making these kinds of videos. Huge library that is over one monthly subscription. That is when it comes to grabbyalien.com/coolworld. Clicking that link helps us out too, so please do check them out. Now back to the video. Okay, when it comes to Grabby aliens, I have 3 major criticisms, so let's walk through these together. Criticism number 1, the hard steps model. Grabby aliens is predicated upon the hard steps model, which we don't know to be true. It may very well be that the development of intelligent life is in fact very easy. It just takes a few billion years to play out. A remarkable feature of evolution is the continual growth in biological complexity, a property that assembly theory argues could even be used to detect life elsewhere. At the end of the day, if intelligence bestows evolutionary advantages, then perhaps it is inevitable given a few billion years. A few years back, I took the chronology of evolution and life on Earth, including our own emergent state, and published a Bayesian analysis of this question. The result was inconclusive. Everything we know about our own history is consistent with either a hard or easy step model. You can check out our earlier video for a deep dive all about this. Okay, so is there any other evidence for hard steps? Well, one might be tempted, as indeed Carter was, to take his 6 inferred steps, look back at the evolution record, and try to identify what those transitions might be. A possible 6th step would be abiogenesis, bacteria, eukaryotes, sexual reproduction, animals, and then civilization. But here's the thing, that is just painting in the numbers after assuming that the hard steps model is true. An evolution biologist could come along and argue about whether each of these were truly hard or easy, or perhaps there might be some other missing hard steps, like photosynthesis, for example. This whole exercise is just way too subjective, and to me, it doesn't serve as actual evidence for the hard steps model. In the original paper, Carter argued that the ace in the hole for hard steps was that it explained an apparent coincidence. Why is it that the main sequence lifetime of the sun is comparable to the timescale it took intelligent life to develop? He argued that there's no mechanistic reason why these two should be connected, but hard steps explains this apparent coincidence since most lucky lockpickers will break through the last door near the end of the allowed time window. Now, I'm no evolutionary biologist, although neither is Carter, but I'm just not so sure that this really is a coincidence. Let me just offer one possible reason as to why. The Earth's environment is obviously totally dominated by the sun, and over the last 4 billion years, the sun's luminosity has increased by 25 to 30%, and that will obviously impact the Earth. The early Earth likely had a CO2-rich atmosphere, but as the sun increased in luminosity, it increased the rate of precipitation and weathering on the Earth, which in turn caused it to pull CO2 out of the air and fundamentally alter the chemical composition of the atmosphere. So the Earth's environment is changing on a timescale that is linked to the sun's main sequence lifetime, and those changing conditions would surely precipitate evolutionary adaptations for Earth's inhabitants. So I don't really accept Carter's coincidence, and without that, the hard steps model lacks any data-driven explanatory power. To be clear, I am not claiming that the hard steps model is definitively wrong, merely that it is unproven, and therefore it serves as a shaky foundation for the Grabby aliens hypothesis to sit upon. Hansen's model not only assumed hard steps, but also that the number of hard steps is a universal value on every planet and moon out there. Given the potential enormous range of diverse environments which life could thrive, I'm not sure I'm comfortable with this assumption either. In the end, there could actually be another step that the hard steps model actually ignores. That is the probability of transition from a human-like civilization to a Grabby aliens one. Perhaps that probability is just incredibly small, and that explains why we don't see them out there in the sky. So let's move on to my criticism number 2, which concerns the treatment of M dwarfs. Even if hard steps holds, this for me is the most concerning issue of the paper. Look, the hard steps model predicts that for sun-like stars, the emergence of intelligent civilization should be a very rare event. That's because the stars have short lifetimes, less than 10 billion years, but each lock might take typically much longer than that in order to be picked. Yet more, the sun-like stars are on the way out. The universe is just not manufacturing them the same kind of numbers that it used to. This fact is also true for smaller M dwarf stars as well, but crucially, those stars should live for trillions of years. So even if the locks are hard to pick, they have the patience to wait it out and eventually succeed. So this poses a problem. In the story of our universe, most civilizations should be born at far, far later times than today around these diminutive M4 stars. Grabby aliens makes the universe itself less habitable over time and thus solves this problem. We were not born a trillion years from now because there's hardly any Earth-like planets left at that point. My whole problem with the solution is that there is a much easier one available to us. That is that M dwarfs are not habitable to begin with. If M dwarfs cannot, for whatever reason, produce intelligent beings like ourselves, then it is no surprise that we don't live in the M dwarf dominated future. There's two reasons why I think that this works better than the Grabby aliens hypothesis. First, we already are accumulating plenty of evidence that suggests that M dwarfs really are a danger to their planets. They exhibit intense flaring and magnetic activity for the first billion years of life that can strip us of their atmosphere entirely. Recent JWST data of the TRAPPIST-1 system has established that the two innermost planets have indeed long lost any thick atmosphere. Super Earths, with their high surface gravity, might be able to resist this process, but they pose other challenges. Many are hypothesized to be ocean worlds, for which technology might simply never develop in an aquatic environment. For example, how you can do combustion. Further, their high surface gravities has been shown to make them prisons for chemical rocket systems, and such inhabitants may simply never have a space age. So we have legitimate astrophysical concerns. But a second reason why I would throw out the M dwarfs is that by doing so, it kills two birds with one stone. Grabby aliens tries to solve the mystery as to why we don't live a trillion years from now when M dwarfs dominate. If instead we remove the M dwarfs out of play, then that obviously solves the same problem, but it also solves an additional problem as to why we don't live around M dwarf now in today's current epoch. I've dubbed this the red sky paradox in a previous paper and video, which highlights that M dwarfs greatly outnumber sun-like stars, and thus the fact we don't live around one now is already kind of weird. Grabby aliens has no way of solving that problem. I think it's actually really interesting that Robin Hanson and myself got interested in the same problem, humanity's apparent early emergence in the history of the universe, in the same year, 2021. But we arrived at totally different solutions. I'll let you decide which one is more plausible. Last but not least, my third criticism, which is best described as philosophical issues. As noted earlier, Hanson's hypothesis has a pretty obvious major issue. Grabby aliens are by definition easily detectable, and yet we don't see them. This point would ordinarily falsify the theory. It disagrees with observation. But to get around this, the theory invokes what, to me, is a kind of get-out-of-jail-free card. It states that the Grabby aliens are all expanding at speeds close to the speed of light. This conveniently solves the problem because, of course, we cannot detect something traveling at the speed of light until it arrives here. A classic example is that if the sun disappeared, we wouldn't know about it for 8 minutes because it takes light that long to travel the distance from the sun to the Earth. For me, this jeopardizes Grabby aliens as what we might call a credible scientific theory, for it means that there is no experiment we can design that can falsify this hypothesis, even in principle. The philosopher Karl Popper used the criterion of falsifiability to delineate science from metaphysics. If a theory cannot be falsified, it cannot be considered within the remit of science. The other philosophical complaint I have about Grabby aliens is a complaint which I've actually had about many other alien topics as well. Look, Hanson points out a really interesting puzzle, the same one I highlighted in my Red Sky Paradox paper. Why do we live in the early history of the universe? Obviously, I think that is an interesting and poignant question, since, of course, I published it already myself. My problem is that Hanson invokes aliens as a solution, and to me, aliens should be the solution of last resort, not first resort. This is just my personal preference, so feel free to disagree here, but time after time, history has taught us to be careful about invoking aliens to explain things that we don't yet understand. What's that weird interstellar asteroid? Aliens. What's that weird pulsating star? Aliens. What's that weird streak on Mars? Aliens. And yet, every time, we were wrong. We have a bad habit of invoking aliens to explain things because it's so damn easy. They can explain everything and anything you want. You know, it's remarkably similar to how the ancients invoked gods and deities to explain why the sun rises, why the rain falls, and why the planets move. I think we can do better. So those are the three major reasons why I don't buy this theory. I think a far simpler hypothesis is twofold. First, M dwarfs don't permit creatures like us to develop on them, solving the red sky paradox and our apparently early emergence in cosmic history. Second, the emergence of aggressive expanding civilizations just doesn't happen for some reason. No need to invoke speed of light colonization waves. Despite my criticisms, I have enormous respect for Robin Hanson's work, and I think this idea is thought-provoking and it intellectually advances our discussions of potential alien behaviors. It is an important theory that deserves attention. And I hope that this discussion provides some counterweight and ultimately shows how we can cordially and respectfully disagree with one another. As always, I'd love to hear your thoughts down below in the comments. I really do appreciate seeing your viewpoints down in there. And if you want to hear my opinion about Dark Forest or other alien theories, please do also let me know down below in the comments. So until next time, everyone, stay thoughtful and stay curious.
All right. Does anybody want to talk about this? These two videos?
So I'm listening, but I'm going to have to talk about it a little later. But
Sure.
I like what he's saying. This guy is pretty good.
Yeah, he's terrific. Yeah, I love him. I mean, he's a leftoid, but he's fine, yeah. Okay, Omnivore is not listening. Does anybody want to talk about it besides Omnivore? If not, I'll come back later. Where's Andrew? Okay, all right. Let me give you the link to my Discord. And so was this guy. There was. So, do you know anything about it? I'm honestly asking if you know about all the stuff leading to it, then I'm glad to discuss it. I know very little about it. If you want to talk about it, I'll gladly talk. I'm curious about solving all of physics. All right. Okay, what do we got? So I was let's see how the audio's doing. Let's see how the audio's doing. Okay, it's doing well. So I think the best thing is to continue. Well, let's see if there's anything interesting. The Dirac equation of the electron and hydrogen Hamiltonian. That looks interesting. Space-time may be two-dimensional at quantum level. That doesn't make any sense. What is this? The process. The horror only gets worse. So I guess he's playing a game. Absolute and relative motion. Newton's spinning bucket.
In book 1 of his Principia, in the Scholium at the end of the definitions, Newton claims that there's a such thing as absolute space, and that there's a such thing as absolute motion through this space. The problem is, it seems like every time we try to measure motion, all we do is measure relative motion, that is motion of one object relative to another. Newton concedes that we cannot identify whether something is in absolute motion, that is motion through this absolute space, for the case of linear or straight line motion. But Newton argues we can determine whether something is truly spinning, that is, we can determine if an object is rotating compared to this absolute space, the most fundamental reference frame of space itself. How does he claim this, or why does he claim this? And this is Newton's famous spinning bucket experiment. So I'm going to now describe the spinning bucket experiment. Okay, so Newton says, I'm going to paraphrase how he does this. He says, consider a bucket of water suspended from a ceiling high overhead. So think about maybe like a cathedral or something with a huge domed ceiling, and there's a bucket suspended from the ceiling. So I'm going to draw here the ceiling. Okay, and I'm going to draw this bucket like this, and a handle on the bucket. And let's suppose that you hang this from a string, but this string, you twist the bucket up like this, so the string is all twisted, so there's a twisted cord from which the bucket is hung. So you spend some time twisting this up, and let me draw the water that is in the bucket. So we got this water that is in the bucket, like this. Okay, so we got this water in here.
Surprise comeback. Dark energy could be holographic after all. No. The holographic principle is nonsensical. What is gravity? 2 years ago. Amber, it's a holiday? So? I don't know what that means. So you are eating Turkey or something. Oh my god, what does that mean that it's a holiday? Let's see if there's anyone here. Omnivore is busy. Okay, let's continue with life. With lice. Lysenkoism. Okay, we'll come back to this. We'll come back. What? Amber says, no, it means we don't use electricity. I can come now because he left. Okay. Well, why don't they use electricity? Like, what does that mean? What is electricity? Like, so they're not electricians? What?
Hey,
So, but electricity, that's so what the Jesus said not to use electricity or something?
we're Jewish. Like, stop talking about Jesus. No one fucking cares about Jesus.
Wasn't Jesus Jewish or something?
No.
Wait, what? He wasn't Jewish? I thought he was Jewish. I thought it was like
No.
wait, isn't he from Israel or something?
That doesn't automatically make you Jewish.
What was he Roman? Was he wasn't he half Roman? Like not Roman, like a
I
thief.
don't know. I don't give a shit.
Like isn't the story that you don't like Jesus? Okay. Anyway,
Why would I like Jesus? It has nothing to do with me.
well, he was a communist. I thought you were like a communist.
Why does that mean I have to like every other communist?
The old comrades or something. I wouldn't know. Like I don't like communists. You know, they're very dangerous creatures. So
Mhm.
so you're not
Do you
using
normally like every member of a group when you like someone?
I in general I like everyone, but communists unfortunately have to be executed on site, otherwise they will destroy the world. I mean, they will destroy the world. It's just a matter of time. Like we're always on borrowed time against communism, but you know, at the end we will lose to to the idiots who define themselves as communists. I'm sorry, I don't mean to hurt your feelings. Um, but
I don't really have feelings about it. Like, I don't care.
yeah, I mean, look, I like you. You're my best friend right now. Um, but I mean, you, you're very dangerous. Your, your lack of knowledge, your lack of understanding, you're endangering me and all of civilization. So, I mean, but you're a nice person. Like I'm sure Stalin was a very nice person, like to his daughter. I'm sure his daughter loved her dad. Like she would never think of him as a brutal uh, mass murderer. You know, Stalin died poor. He didn't have any money in his bank account. Like he was a real ideologue. I mean, he was really interested in communism, in Marxism, in equality. Are you crying?
No, I'm trying to blow my nose. I'm pissed off. My dog like ate my glasses and I don't know how she even got them.
No way.
Yeah.
Like completely chewed them up?
She got one of the arms completely off and I can't get it back on because she broke the piece off, so
Jesus. I'm so sorry.
I'm really pissed. Like they were on a dresser like far away from her, so I don't get how she got access to them.
Mm.
I was like, I don't know, I'm just really pissed off. I just wanted to hang out today because he's at the synagogue, and like now she gave me something else to worry about. Those are over $100. Like I got the cheapest ones available, and they were still $110. So
Yeah.
like I don't know what the fuck I'm gonna do because those were my only pair of glasses. They should really make it easier to get glasses in this country.
Right. So, the US is kind of communistic when it comes to certain things. When it comes to glasses, the US is very communistic. Like, you can't, like, if I want to produce glasses, I can't. I can't.
Yeah, that's very fucking annoying. And like
Yeah.
the fact that people know about it and it still is happening is weird. Like
Well, that's communism, right? You want communism, so here is a taste of communism.
that's not communism. That's literally capitalism.
No.
That's a monopoly in action.
Capitalism means freedom, that anyone can do anything they want. Capitalism is
Yeah, that's the freedom to oppress other people. Like that's literally what they're doing.
no, capitalism means anyone can produce, like I can make glasses for you. That's capitalism. If I cannot make glasses for you because government will stop me, then that's not capitalism. And that's you are against freedom, like market freedom, like economic freedom, right? Communism is against economic freedom. And and that's what now you can taste it when you have to pay $100 for a piece of plastic. That's all it is. And that's a taste of communism. They restrict production and purchase. You cannot purchase, like, maybe you can purchase glasses cheaper from Canada because they actually have more economic freedom when it comes to like medicines and stuff, or from South America. I don't know. But the US is terrible. Like, you also have to have an eye exam that itself costs like $100. Like in other countries, you just go to the store and order glasses. You tell them, the number, and they make you the glasses right away, basically.
Yeah, like I have the information, but typically people will be like, we want that to be taken within a year because they think it's going to change too much.
No, what I'm saying is, like in other countries, you just go to the store and order glasses. You don't have to have an eye exam that costs in itself like $100. Like in the US, I remember I got glasses, so you can't just go to the store and order glasses. You have to get an eye exam that cost me, like, at that time, over $100. And I didn't need an eye exam. I have glasses. I just want to make new glasses. My old glasses got scratched up. I needed new glasses. I could go to the store, show them my current glasses. They would test it and reproduce it. But in America, that's illegal because the eye doctors have a monopoly, as you say. Nothing to do with capitalism. It's the opposite of freedom. They work with the government to oppress me. So I have to go to an eye doctor, even though I don't want to go to an eye doctor. They're forcing me to go to an eye doctor to get prescription. I don't need the eye doctor. I don't want the eye doctor. I want glasses. I'm willing to pay for glasses. I don't need the eye doctor. This is like racketeering. This is literally racketeering. Government forced racket. Do you know what racketeering is?
Yeah.
So that's all it is. There is a mob. It's called government slash eye doctors. And I don't want their service. It's like, I don't want the mob to protect me, but, I don't have a choice. I have to pay the mob to protect me. I have to pay the eye doctor for a prescription. Even though I don't want it, I don't need it. It's a service I don't want, I don't need. Leave me alone. No, you have to pay the eye doctor $100 or whatever, $200 to conduct an eye exam. I don't need an eye exam. What are you talking about? What are you crazy? Yeah, you have to get an eye exam. So that's government. That's not freedom. That's like in countries that have actual capitalism as far as eyeglasses are concerned. You don't need to get a prescription. You just go to the store, order glasses. You tell them whatever glasses you want, or you show them your old pair. They reproduce it. They follow. They can tell you right away the prescription you have in your old glasses, and they make you new glasses. Done. So enjoy your communism. At the end of the day, you're gonna get North Korea with all these government demands.
North Korea is literally a democratic Republican
North
party,
Korea.
so
North Korea is a democracy?
yeah,
Are you being serious?
yeah, it is.
What do you mean? Yeah, it is. It's a democracy. It's not. It's not a communistic dictatorship.
Yeah,
What? Yeah, it's a communistic dictatorship or a democracy.
it's a democracy.
It's not a communistic dictatorship.
Yeah,
Which? What do you mean? Yeah, it's both.
it's literally in the name. It's the DPRK. It's not like a communist state.
Why is the name relevant to the discussion? Like if I call
Because
myself
it's not communist. It's
wait, if I call myself a multi-billionaire, so am I a multi-billionaire?
that's different
Why is that different?
because you're not a government.
So if I call myself a government, then am I a government?
I guess.
You guess? Are you there?
Yeah.
Did you say I guess?
Yeah.
So what do you mean you guess? I'm asking you. If I identify as a government, then am I a government? Yes or no?
I just don't care. This is so stupid.
You know. And that's why humanity is doomed. Anyway,
Like, how am I supposed to have a conversation about this if you're gonna judge every communist as like the same person?
I'm not judging any communists. I said I like
I
you.
mean, you literally are. Like, you think like every communist government is the same. There are like plenty of communes in the United States that operate fully functionally. So,
I,
how is communism in and of itself the problem?
well, so you just asked a bunch of questions. We can discuss each
So
one.
that's not a bunch of questions. That was one question in multiple statements.
So ask again if you want to talk about something, then ask one tiny question, not
But I
one.
don't care about your answer because I already know what it's gonna be, and I just don't care. Like there are some people who hate communism on principle, and I understand that. That doesn't mean that your opinions are correct or relevant. They're especially not relevant to me.
I don't. What do you mean hate? Okay, I don't know what it means. There are people. You can talk to me about me, and I don't hate. I used to be a communist. I don't hate communism on principle. I hate communism because I know that it ends up as North Korea, and I don't want humanity, civilization, to end up as North Korea. I'm trying to save
I
humanity.
don't see how you can say that. Like, it's not like you were in North Korea and you saw that communism was the problem or something. Like, that's not the case. Communism didn't lead to North Korea in the United States. So why would it lead to North Korea anywhere else? Why is that the sole thing responsible for North Korea?
So the way I understand how North Korea became North Korea. Well, first of all, do you agree that North Korea is the worst place on earth?
Not necessarily, no.
Okay, what's worse than North Korea?
Different African countries,
Name one.
Morocco, Gaza.
Gaza is worse than North Korea?
Yeah. Lebanon is worse than North
But
Korea.
anyone from Gaza can leave. You can leave. You don't have to stay in Gaza. It's everyone who's there is by choice. You can leave. There's Americans with American
And why are they begging for money and
Hold on.
like
Wait,
begging us not to blow them up?
1 second. You do realize there are Americans with American passports and American citizenships living in Gaza. You realize that. You realize that, right? Yes or no?
There are Americans all over the world.
No, no, no.
What the hell does it matter?
No. You realize anyone in Gaza can leave. No one is there against their will. Not a single person in Gaza is there against their will. Not a single one.
Obviously, they can't if they're getting blown up and they're crying about it.
No. They can leave. No one is stopping anyone. They can leave at any time.
That's just stupid. That's like when you're in an abusive relationship and people are like, "Oh, well, you could just leave."
Yeah. What?
Well, yeah, the guy is beating you and he's gonna track you down. He's gonna kill you afterward, but you can leave. No big deal. It's just stupid. Like, obviously, if they don't have the resources, then no, they don't. That's like saying they have food when they're poor.
There's Americans. There's Americans.
I'm not gonna.
What?
This is stupid.
All right. Anyway, so President of Earth is asking me. So I asked him, do you want to talk about some problem in physics? So he says, I would suggest understanding calculus, differential equations, SR, special relativity, quantum mechanics, quantum field theory, gauge theories, symmetry breaking, and after some months of studying them, you can try to have a smooth conversation. It's a big, deep subject. The deeper you go into physics, the greater the understanding you need. It takes time to fully comprehend and connect all modern physics together. Okay, so he doesn't want to have a conversation, I guess. Let me know when you want to have a conversation. But every time I talk to him, he just makes fun of me. It's like I'm offering him, you want to have a good conversation, so he says, no, you have to prepare, you have to go study, study, and after a few months, yeah. But meanwhile, every time I have a conversation with him, he just makes fun of me and mocks me in front of everyone. So for that, apparently, he has time to make fun of me. But to actually have a conversation about physics, no. I need more time to study. I'm not ready for his big brain physics. Yeah. Do you want to go to different servers to talk, to debate people?
I guess so. Where do you want to go?
Let's see. I guess politics is like the go-to. I
guess, yeah.
Do you want to make a room or I'll make a room?
I've already made it. I just have to join.
Really? Where is it?
Yeah, it's like automatic. When you do create a room, if you join again, it will do it.
Looking, found someone, I would say. Gotcha. La 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 la. All right, let's wait. Let's wait. What do we got? Oh, there's 2 people watching us. So I was actually watching videos about Grabby aliens and stuff like that.
In the bucket, okay? And before you release the bucket, so it's all twisted up. Before you release the bucket is at rest with respect to, I'm going to write WRT, so I don't have to write with respect to the room, or this big cathedral, right? So it's sitting still with respect to the room. It's not in relative motion compared to the room. The water, also, that is in the bucket, is at rest with respect to the room. Once again, it's sitting in the bucket. The bucket's at rest, the water's at rest. So the water, this goes perhaps without saying, but I'll say it anyhow, the water is at rest with respect to the bucket. Okay, so there's three kind of straightforward observations. And the last straightforward observation is that the surface of the water, if you were to look into the bucket, you'd see the surface of the water is flat or plane, right? So it's not curved at all. It's a flat surface of water up here. Okay, good so far? Nothing confusing here. Now, let's suppose that you suddenly release this bucket. The cord was all twisted up. So what happens just after you release the bucket? So I'm going to redraw the bucket here. I'm going to try to draw it to look the same. Okay, so you release the bucket, and just after you release it, the cord begins untwisting, and the bucket begins to spin around, right? But just when it begins spinning, the water, which had been sitting still, just as the bucket begins to spin, the water hasn't really begun to spin yet. So I'm going to draw the water in here, and I'll write down these observations like I did a moment ago. So just after you release the bucket begins spinning. The bucket spins with respect to the room, right? So it is now spinning compared to or relative to the room. The water, however, at least initially, so it still is at rest with respect to the room, right? Because it hasn't begun spinning yet, okay? So what does this mean? If the bucket is spinning compared to the room, but the water at rest compared to the room, it means the water is spinning with respect to the bucket, right? Because if the bucket is spinning but the water is not spinning, then compared to the bucket, the water is spinning. So if you're like a bug resting on the bucket but it's spinning around and you look down at the water, it would look to you like the water is spinning compared to the bucket. And finally, the surface of the water is flat, right? So it's still a flat surface of water, okay? But what happens as the bucket is spinning? The water is going to begin spinning along with it. It's going to kind of speed up the edges. The walls of the bucket are going to exert a viscous force or a drag on the water, which gets the water.
Hey.
What up?
What up, Victor? What do you want to talk about? Well,
I don't know. What are you here for?
we can talk about aliens. Do you believe in aliens?
No, that's boring shit.
Really?
Yeah, man.
Do you think humanity has a future in the stars, or are we doomed?
I mean, I would rather read a book of Harry Potter. Same shit.
Rather than talk about aliens?
Yeah, it's still like same shit, you know?
Oh, you think it's science fiction? You think it's just fiction?
What? Of course it's fiction. Why? You think there's aliens around?
I mean, right, there might be other planets in the universe that have...
There might be unicorns, bro, but I'm not gonna fucking read a book about unicorns. The fuck?
No, but the question is, there might be other planets.
There might be unicorns, bro.
Yeah, let me just finish my sentence. Unless, I don't know.
You literally were finished with your sentence.
What?
Why'd you stop talking, man?
I let you interrupt me, but if you keep interrupting
Because I'm not interested in what you got to say. Like, you keep talking about aliens.
Wait, you're gay?
No, that's just your perception because you're gay.
Okay. No, you sound like you're gay, but fine.
That sounds like a compliment to me, bro.
No, I'm not judging. I can tell by the way you speak.
I am not judging you because you seem like the professional in the field.
No. What professional? What field?
In the gay field.
I don't care one way or the other. I'm just saying
you can't call me gay, bro. Like, I came in here and there's two of you in here holding hands and kissing each other. You can't call me gay, nigga. Have you ever heard the way you sound like, nigga?
I didn't call you.
There's nothing straight about you.
I don't care. I didn't call you.
You have a weird voice, my guy.
I'm observing the way you speak. I'm observing. I noticed a tinge of gayness. That's all. I'm not judging you.
Bro, it's not even just you. I get that everywhere by other gay people.
That's okay.
The moment I open my mouth, some gay person tries to put their dick in it. That's just a fact, my guy.
Oh my god, that sounds awful. I'm sorry.
Immediately, every gay person in the room opens their mouth.
I know. Look, I know gay people
that tries to call me gay.
That's literally how gays are.
I'm the only one who has a girlfriend here.
I know. Look.
How do you explain that?
No, it's fine. No, I'm.
You
But
don't even have a girlfriend, so you're definitely more gay than I am.
look. I don't care.
Yeah,
I don't.
sorry about that.
No, it's okay. I don't care.
I know you like my voice, bro,
Oh
but I
my
don't
god.
swing
I
that way.
don't care. I don't care. I don't care. It's fine. We can talk about
You
anything.
keep saying you don't care, but like you're telling me what the shit you think, and I'm
It
supposed
doesn't
to.
matter. I asked you if you're gay. If you want to talk about it, it's fine. You don't want to talk about it, it's not. It's also fine.
No, I
Then
am talking about it, bro. You're
we-
trying to stop that shit because
I don't
it
care.
looks like you're a little bit gay.
I don't care if I'm
Let's
allowed
talk
gay.
about it.
I don't care if I'm
Let's
allowed.
tell everybody that you're gay, bro.
Tell
Like why you're
everyone
so...
what I don't care. It's boring. Let's talk
But
about any.
like if you have skill to detect when people are gay, why don't you just embrace it?
Yeah, I have a lot of skills, not just to tell if
Yeah,
people
you
are
do.
gay. I have other skills. Anyway, I
Yeah, I
help.
know. And that's
I
kind of gay, so I wouldn't be
It's
interested in all
fine. I don't
that.
care. I help Muslim women.
Honestly, my girlfriend would kick my ass, to be honest.
Great. I right.
She
That's
would.
great. I know. I mean,
So you're literally trying to get me in trouble right now.
no,
Stop
no.
calling me. Damn, that was so flamboyant.
Look, I'm
Why do
sorry.
you sound like that, bro?
Jesus. Okay, can we talk about anything else?
You're the one who started this shit,
And
bro. Like
so
I
give
put
so
your
I
little ass in your place, and then you immediately said that I sound gay. Thank you for the compliment, but it's a little bit too early for those.
all right. Can we move to a
You
different?
sound older than my dad, and it's
Can,
very strange that
I'm
you're
an old
talking
man. Can
perversion.
we move to another topic? I think we're done with the
You started with aliens, and I told you it's boring, okay? You don't
and
have to call
gay
me
is
gay for that.
boring too. So let's move to a different topic. Do you want to talk about North Korea? Are you a communist?
You have other people here too. Like I don't need to talk all the time.
All right, Mr. I help Muslim women leave Islam. Do you want to talk?
Yo.
What's up? What do you want to talk about? Do you want to talk
I
about
like his
aliens?
name.
Your audio is very low. You're on max. So can you fix your audio?
This is a conspiracy channel.
Is it?
No. This is an anti-conspiracy channel. Anyway,
No.
Muslim
There's
women.
nothing truthful about you. You called me gay the first thing when I
did
came in.
not call
Okay,
you.
hold on, Mr. Slave.
Yes.
Do you think? Because this is my opinion, but do you
Raise your
think that?
voice. I can barely hear you.
Huh?
Raise your voice. Get
No,
closer.
you
his
hear
voice
me?
is fine, bro.
Yes, much better.
Your mic
Okay.
is lower than his. What are you talking about?
Do you think, in your opinion, or what's your opinion? But do you think that the Jewish accent, when they speak English, any accent in the world that speak English, right? But the Jewish accent is the worst accent in the world.
That's subjective.
I guess if you hate
Objective.
Jews, like I don't have anything against Jews.
No, they just no. It's not that has to do with that you hate Jews. You just happen to have like the worst one.
Like imagine a hot chick that happens to be
Like a Russian speaking English accent, right? That's okay. A French speaking English accent, that's okay. But the Jewish one, it's not really that great.
Look.
Wait, what do you mean Jewish?
Like the Hebrew, whatever. Like when you're
the
just
Hebrew.
Jew born in Israel and you speak
It sounds
English,
French, doesn't it?
you have that weird accent.
It's like a French person speaking English.
I don't care. It's like if it's a hot chick, I don't care how she speaks. I would love how she speaks. I don't care. I love accents or no accents as long as she has perfect body and perfect face.
He's coping. He's gay. You just told me earlier that you're gay.
Fine, whatever you want. Let go of the gayness. I don't care about gayness. Please, let's talk about either aliens or you want to talk about. Wait, somebody. He left. Okay,
Of course he's
Vector.
gonna leave.
What else do you want to talk about besides gayness? Because gayness is boring.
Okay. You can't flip that shit on me. You started that shit.
So you don't want to let it go. So all you want to talk about is gayness.
No, it's not that I don't want to let it go. It's just you started it, so I was talking about it a little bit.
So can I finish
I don't
it?
have to talk about it.
All right, let's. So what do you want to?
No, I'm not gonna let you finish it.
No.
I always have more to say than you do because
All right,
you're
fine.
suffering from the tiny mind syndrome, and I know it.
Oh my God. Do you want to talk
You're
about
struggling
anything?
with English too, bro.
All right. Do you want to talk about anything else besides nonsense?
Conspiracy? No. That's all you want to talk about is just nonsense.
Okay. What do you want to talk
Aliens and
about?
shit.
Okay. What do you want to talk about?
No, this is your channel. Like, what are you talking about?
I'd rather talk about, as I said, we can talk about aliens, we can talk about quantum mechanics, special general relativity, physics.
So you're not a flat earther?
No, I'm not a flat earther. I'm a completely normal physics person. I'm a normal
No
mainstream physics.
You study physics
A little bit.
in Germany?
I don't disclose my location.
Of course you don't, because you're in some third world country. Like you're embarrassed of your own homeland.
I don't care. Let's not talk about me. Let's talk about the universe. Why does
You don't
everyone?
disclose shit because if you did,
Ugh,
nobody would actually take you seriously.
I don't care. Can we talk about the universe, not me?
But like, it's as if like when you open your mouth, people don't know where you're from.
Hello.
Polish plumber. Are you Polish?
Yeah,
Are you
but I'm
from,
not a plumber.
are you from
I'm
Poland?
an accounting student.
I have him
Yeah.
muted for some reason.
So you live in
They don't like
Poland?
the Polish plumber. No, I live in London.
But you were
No,
born
he's a troll. He likes to talk about like
you were born in
children and
Poland?
You're a
sex with
fucking troll.
them.
Vector, stop.
You're a fucking
Calm
troll.
down, nigga.
Okay, Vector, I'm gonna mute you.
Oh no. Vector's gonna be so sad.
Done. All right, Polish plumber, you can mute Vector. I don't care about him. He's boring. And he left. Good. So Polish plumber, were you born in Poland?
Yeah.
So you're studying to be an accountant in London?
Yeah, I'm gonna change my degree though. It's only the first year, so what I'm gonna do, I'm gonna study computer science because you can still get into because if you study accounting, you're gonna make good money. Not that good money. It takes 5 years to qualify.
Mm-hmm.
It's not even worth it. It's much better, right? You don't really want to be an accountant. If you want to work in finance, you want to be a fucking quant. You want to be a quant director, right? You want to make you want to do maths, and then you want to make financial decisions.
So study math.
You want to study computer science, right?
No.
Because you're going to be coding.
No.
So
I would
tech is if you study computer science, you can get into finance.
look,
If you study finance, you can't get into tech.
learning to code is easy. Learning math is hard.
Mhm.
I would study math because at the end of the day, for anything you need math. Math is always the most
Yeah.
important thing. So I would study math. That's all I would do.
I think the best thing to do is if you want to make a lot of money, become a quant director,
I understand.
quantitative finance director.
I understand, but for that you need math. Computing skills, like programming skills, that's easy. That's like really easy.
Yeah, you need a master's degree. So you want to get a master's degree in quantitative finance somehow.
You can
There's
get
two ways: computer science or accounting.
I would get even a PhD in math. I would just become a mathematician and
Yeah.
and do quant. At
Yeah.
the end of the day,
So study quantitative finance
no, I would
and master's degree.
I would
Then
do a PhD in math. I would just go all the way, become just a mathematician. Just become a mathematician and apply it to finance. That's what I would do. At the end of the day, math is the most difficult challenge that I'm facing in my life. Like whatever I want to do, math is always the biggest challenge. Like computing
yeah,
skills are easy. That's like really easy. Like anyone
programming skills.
yeah.
It's not easy. It's quite difficult. But you can use ChatGPT. Here's the thing.
Yeah.
Right now we have ChatGPT.
Yeah.
You can just say, "Oh,
Yes.
ChatGPT, code me a snake game,"
Exactly. But
and it's gonna code you a fucking snake game.
Yes.
Oh, ChatGPT, can you code me a calculator?
Yes.
Can you code Google too?
Yes. Yes. I wouldn't bother with learning to code. I would bother with learning math. Just math. Just become a math fanatic.
Mhm.
Become a genius in math, and that's it. and then apply it to finance, either quant or schmant or bond, whatever you want. Anyway,
ChatGPT.com. I'm gonna try to get ChatGPT to make me a search engine.
Well,
the code for a search engine.
A search engine is really simple to build.
Can you code me Google?
Wait, Polish plumber.
Two.
It doesn't matter. What else do you want to talk about? So, what do you think about aliens?
Can you code aliens?
Yeah.
I look like a fucking alien.
No, I don't care. What do you think about aliens? Why
Or
aren't
big head.
do you believe that there's aliens in the universe besides us?
Of course.
So
Yeah, of course.
So why can't we see any bless you? Why can't we see evidence of aliens? There's no evidence.
I just coded Google. I just coded a search engine. I swear to God.
Look, do you want to talk about aliens or something else? Do you want to talk about North Korea? Do you want to talk about? Are you a communist?
Yeah.
Okay, so you want to talk about communism?
I'm gonna try to. I'm gonna try to code Google too.
I don't care. I don't care. Like
search engine.
Oh my god. Okay, you don't want to talk?
No. I'm gonna have to. I want to code Google too. All right. I'll see you later.
Later. Bye. Okay. Let's get back to the video. Where's the video? You know what? Let's hear what she has to say.
Most surprising physics. One of the most surprising physics discoveries I've seen in my lifetime was dark energy. It was so surprising that the first time I attended a seminar about it, everyone was sure this was a measurement error. It wasn't. Dark energy seems to be real, but physicists have no idea what it's made of.
Hello.
Hello, sir.
Hello, Grim. Do you want to talk about
Hey.
aliens?
Aliens? What about them?
Do you believe there's aliens in the universe?
I think there is a high probability. There is a chance,
Then
I don't think that we have evidence, but there is a high chance, yeah.
Then why can't we see any evidence of aliens?
Why can't we? Maybe the evidence didn't travel to us, the information. It didn't have enough time to travel to us.
So
or maybe it's information in a way we can't interpret it,
So
or we are misinterpreting it.
So you're saying there's very few of them, or they just started living their lives? Like, we didn't get the information yet, so
Yeah. Light speed is like limited, right? So there is like a maximum speed the light can travel, and therefore like information can travel. So, and the universe is pretty fucking big, man.
So you're saying that there's very few aliens, very, very, very few. Like in our galaxy, there's no aliens, basically.
In our galaxy, there might be some aliens in our galaxy, man.
Then
you might be an alien as far as I know.
But we can't see. When we look at the stars, we don't see any aliens. There's no evidence of anything. There's no evidence, nothing. All the stars look dead. Everything looks dead. Why can't we see any evidence of anything? There's nothing. Anyway,
other than the answers I just gave,
so you're saying right?
I don't know.
So you're saying there's very few.
Yeah, we're having a Fermi paradox conversation.
We're doing the aliens. Yeah, the paradox. What's his name? Fermi's paradox. Where are the aliens?
Yeah, I think life is just rare.
That's very unlikely. So it's like, what do you mean life is rare? So we're the only ones in the galaxy, in the universe?
The only ones making radio signals at the moment. In our galaxy.
But you realize that's very unlikely, because life on Earth started as soon as Earth cooled down just enough. So life on Earth is as old as Earth's crust. That means life waits basically for the proper conditions, and it pops into existence.
But what about complex life? And what about stable geology and climate over billions of years?
Right. I mean, that's just, as soon as you have life, I mean, nothing can stop, right? And evolution starts, and there's a survival war, and the survival war drives predator and prey to evolve. So before you know it, you have
That's all true,
humans.
but complex life didn't happen until only 1 billion years ago.
Fine, but maybe right.
Yeah, Cambrian explosion.
Right. So you're saying we should be able to find plenty of green planets, like with
Maybe there's sludge everywhere, bacteria and stuff.
like there's blue planets, like oxygen planets everywhere with photosynthesis. So we should be able to find a lot of blue planets. Okay. Well, I don't think we've started looking for blue planets yet, but you're saying
not quite there
right,
yet.
But you're saying that that's the great filter.
I think so. I think the great filter is complex multicellular life.
Okay, what's the big challenge about multicellular? Why is that such a big challenge?
Because you need a very stable climate.
Why do you? I mean,
this shit's delicate.
So basically, for 3 billion years or so, we were single-celled and did not evolve. During the 3 billion years, was there any evolution of single cells?
I mean, I'm sure there was. Just not in the way that leads to differentiated structures.
So these single cells, were they prey and predator and prey? Was there? I'm sure there was predator and prey relationship. So wasn't there like?
I mean, probably, and I mean, there's different kinds of multicellular life also. Like even bacteria are able to specialize a little bit, even though they have the same genome. But we're talking about like a more complicated version of that. So there are. I mean, yeah, there would have still been predator prey and all that kind of stuff.
Fine, but
still happening.
Okay, yeah. So what you're saying is that it's just very, very unlikely, or it takes time for civilizations. That's why we don't.
I once heard the metaphor that it's like a number of locks that you have to pick, and you have like 6 or 7 locks, and you can pick them really fast, or you can pick them really slow. But for us, maybe it took 3 billion years, 4 billion years.
Wait, how does I heard this lock analogy in the Grabby aliens, but I don't understand it. So how does the locks analogy, like, so what if
so they're requisites for the kind of complex life that we are,
obviously,
and it's like when you pick the life, when you pick the lock, it's unlocked, and some people can pick the lock really fast, and they're like, what's the big deal? But some people never can.
So how does that solve anything? How does that explain anything? Where's the
It doesn't really. It's a possible explanation that some places just haven't gone through the proper milestones yet.
I mean, obviously, that's basically the Drake equation. All you're saying, there's a Drake equation. Obviously, there's a Drake equation. There's a bunch of filters, obviously. But the question is, we are a civilization. So I would say, statistically speaking, there should be others. There should have been others. The universe is 15 billion years old. We're around 4 billion years after the planet started, after it cooled down. So there should be other civilizations, since the universe is about 5 billion years old. That means since 10 billion years ago, there should have been already civilizations. Now, 10 billion years, we should be able to look at a bunch of galaxies. I don't know how many billions of galaxies are within a sphere of 10 billion years. Now, we should be able to see techno-signatures.
What are we looking for, though?
Just techno-signatures. What do you mean? They should be everywhere.
I'm not seeing any techno-signatures.
Right. That's the paradox. Not just techno-signatures. They should have spread. And when they spread, they should have been on Earth as...
I mean, I'm not so sure that we are giving out very clear techno-signatures. So maybe Alpha Centauri can detect us.
Well, maybe not yet. So, look. So my theory is that we're doomed.
Oh boy, I don't know about doomed.
Because if we have hope, then other civilizations had hope, and they would have spread. They would have gotten to Earth, and they should have been here, and we should not have been here because they should have been here as we were bacterias. They should have conquered this planet as it was cooling down, as it was becoming blue. They should have conquered it and settled it. They should have conquered the universe. But
I think give us 1,000 years.
That's
We'll get out there.
So I think we're doomed. I think all the aliens obviously are doomed. All the civilization.
So like what's it called? Alistair Reynolds type situation.
What does he say?
That was a sci-fi author. That there's like a super intelligence that kills off all the other intelligences.
No, that does not resolve Fermi's paradox, because Fermi's paradox is only resolved by a 100% mathematical certainty solution. You can't have less than mathematical solution. You can't have one killer because he's always going to miss one guy.
I think we're the first.
That's unlikely. That's unlikely because life evolved on Earth as soon as Earth cooled down. So 10 billion, at least I would say 10 billion years ago, we should have already seen civilization. So we should be able to look up and see. We should not be able to look up. They should have been here instead of us. Why are we here is the real question. They should have been here when we were bacteria. And they should have settled, and we should never have had a chance to evolve. The fact that we're here says we're doomed.
Well, enjoy it.
Yeah, but I think we're doomed with mathematical certainty. So are you a communist?
Not really. I think money's pretty cool. But I think like I'm a replicator communist, I guess you could say. Like when we're all in Star Trek technology, we're not going to care about money.
Yeah, we're doomed. If you believe that. So you believe in infinite economy? What do you call it?
I don't know about infinite, but the galaxy's pretty big.
No, but
I'm sure we could fill it up with soda cans.
No, but what do you call the like when everybody has no lack? Everyone.
Yeah, like a utopia or cornucopia or whatever. Everybody has everything.
Right, but it has a name when no one, like everyone's needs are fully met.
Utopia?
Yeah, but it has a different name when everybody's okay. What do you call it when everyone's needs are met? It's a type of an and it's like a science fiction economy. Of course, like I I don't talk to people about these topics. I forget.
Like a post-scarcity economy?
Post-scarcity, yeah. So you believe in post-scarcity?
I do. I mean, it depends on what level we're talking about. Like,
it doesn't matter.
Like if we chew through a galaxy's worth of mass, then
it doesn't matter. Post-scarcity is a violation of rationality.
I don't mean like literally infinite, like post-scarcity.
It doesn't matter.
Just like
it doesn't. Just the very notion of post-scarcity. I mean, scarcity is.
It's more of a philosophical debate, and I agree with you. Like, there's no such thing as actual post-scarcity. We're always going to want something.
Like everybody will always want more. Everybody wants more. Like you give me a palace, I'll want more. I'll always want more. So post-scarcity is a violation of rationality. I'll always want more. You'll give me a planet to own. I'll want more. You'll give me a galaxy.
Maybe that's the irrational part, though.
No, that's the definition of rationality. The definition of rationality is that you want more of a good over less of a good. That's just definition of rationality.
I'd be pretty happy with my own solar system.
That's what you say, but as soon as you have a solar system, you'll want more. That's rationality. Assuming you are rational, you'll want more. So so post-scarcity is a violation of rationality. which is a violation of the science of economics. So you can't have both. You cannot have the science of economics and believe in post-scarcity.
I mean, I think we're so far off from having to worry about a second solar system that I'm not too worried about it.
I'm not saying.
But I agree with you. You are right. You're right.
Wait, you're black.
I think there's going to be like a resource abundance relative to want. How about that?
Wait, but
and it'll plateau for a couple million years or something.
Wait, are you African American?
No.
Oh, I heard like in your voice a little bit of African American.
Interesting.
Yeah, you have like a little bit African American voice. You're totally white?
Pretty white.
You're not a little bit mulatto?
Not really.
Amazing. You gave me a African American vibe, like an African American genius vibe. Anyway, so so do you know why we're doomed? Do you know how all the aliens? Okay, so it's pretty conclusive that all the aliens died. So what killed them?
Maybe they're just being quiet.
Impossible.
Maybe they're shouting from
Why?
the rooftops and nobody's listening to them.
No, we would see them. No, you could say that they're all alive, but their voices are suppressed. We can't hear them because they live under a suppressive government.
I mean, we're shouting into the void and nobody's answering.
Well,
so how come it's different for everybody else?
Yeah, I mean, right now when we're shouting, I mean, the planet is lit at night.
You got a bubble of a couple decades, a couple light years, couple decades of light years
right
around us.
But those civilizations from 10 billion years ago, we should be able to see them by now. We can't. So
there's like 1,000 stars that can watch I Love Lucy right now.
Okay, so why can't we see them? So you're saying that there's
I'm actually not sure that they could see us.
Fine. Let's say they can, but why can't we see them? Why aren't they yelling like we're yelling?
What I'm saying is they might be, and I'm not actually like I'm being kind of glib, but I'm not sure that they could watch I Love Lucy,
so
like even from Alpha Centauri.
Fine. Look, it looks like they all died, or they're all alive, but something is keeping them quiet. The question is, why? Where are they? What's going on? And whatever the answer is, that's going to doom us. Whatever is dooming them is going to doom us, because it looks
That's
like.
not true.
What do you mean?
They're already here, dog. Where do you think the cows keep going?
What? Cows?
The cows.
What cows?
Where do you think they're going?
What cows? What are you talking about?
They're abducting the cows.
What's your evidence?
Newspapers.
What's your evidence that aliens are abducting the cows? What's your evidence?
Newspapers.
Okay, you're not gonna present me evidence, so you're talking, you're lying, right?
If you don't read the local news in your city,
present the evidence, or I'll declare you to be a liar. Like, you cannot.
I am not a liar.
Then when you go to court and you express an opinion, they ask you, what's your evidence? Either have an answer, or the judge will kick you out of court and fine you for lying.
Do you think this is a court? I'm not the one mistaken here, brother.
Okay, so either present your evidence, or I'll declare you to be a liar.
I'm not a liar.
Then what's your evidence? No evidence. Then
you can call me a liar, but it don't make me one.
You're a liar because you're stating things with no evidence. That's called a liar.
No, that's not what a liar is.
Yes, it is. That's the definition of a liar.
If you tell me you got a daddy in your bedroom, and then you don't show me your daddy, that don't make you a liar.
What daddy? What are you talking about?
That just means you ain't proven to me that daddy's in your bedroom.
What's a daddy? What does that mean?
Your father.
My dad is in my room. Okay.
Yes.
If I
that wouldn't make you a liar.
If I don't present
make
evidence,
you someone not wanting to show me your room.
Fine, then you have an excuse. But what's your excuse for not presenting evidence about aliens?
I don't need one, just like you don't need one.
You're a liar. No. Look, you need an excuse. Give me the excuse why you're not producing evidence.
I just told you.
No, you didn't. You didn't give me the excuse why you're not producing evidence.
All right, let me explain it to you again, young buck. So you could tell me your father is in your room, and I tell you to prove it to me, and then you're like, no, that don't make you a liar. That just makes you lazy.
Whatever. Give me the excuse why you're not producing evidence. Come on. Otherwise, you're wasting my time.
I just told you.
Did not. Give me the excuse. Why are you not producing evidence that the aliens are?
I just told you.
No, you didn't. Okay.
Son.
All right. You don't want to talk? Fine. That's fine. Let me know when
you clearly don't like cows.
Let me know when
they're being abducted and you don't even care.
All right. I don't care. I don't care. You don't have any evidence. I don't care.
In a recent paper, 2 physicists now claim that it isn't made of anything, but instead a consequence of our universe being.
Look, I don't care. You don't want to talk seriously. What do you mean? Do you want to have a serious conversation? Listen, do you want to have a serious conversation? Otherwise, I'm not interested.
I'm trying to right now, but apparently you don't care.
I don't care about what? Dairy products?
The cows.
Which cows? From the alien abduction? I'm gonna mute you because I want to do other things. So it's up to you. You want to have?
You're mean.
Yeah. You want to have a serious conversation? That's fine. You want to have?
I just tried to. You're the one who won't have it.
I'm not gonna talk about nonsense. Good. Goodbye.
Holographic. Let's have a look. Genuinely new ideas are rare.
1 second. Let me get back to my server because Amber is not here, so it's pointless. Okay, we're here. Somebody wrote something. Once you almost fully understand the subjects I mentioned, but the funny thing is that once you do, there is nothing you can add to them. Okay, let me know when you want to talk. Don't waste my time. People love wasting time. They just love it. Just waste time. Let's just waste time. Do nothing but waste time. Let's get back to this guy.
Water spinning as well. So what happens after a while? After a while, the bucket is going to be spinning, and the water is going to be spinning right along with the bucket. And at least momentarily, there will be a time when the water is going to be spinning at the same speed as the bucket. So this is when the string is totally untwisted. Of course, it's going to start twisting the other way, right? It kind of overshoots. But at this moment, when the string is totally untwisted, and the water is going to be spinning along with the bucket. So I draw like this. So here, the bucket is spinning with respect to the room, right? And furthermore, now the water is spinning also with respect to the room, right? Because it's spinning along with it. And at least at some moment in time, the water, because the bucket is spinning and the water is spinning, at some moment, the water is going to be at rest with respect to the bucket. And finally, the surface, I'll draw the water in a moment, the surface of the water is going to be curved. It's going to be kind of riding up on the side of the bucket. So I'm going to draw the water kind of like this.
It's a parabola.
If you look at the surface of the water, you would notice that the surface of the water is curved. Right?
It's a perfect parabola, so much so that they have a plan to make an actual lens, liquid lens.
Okay. And then finally,
that's going to be as big as you want. Like you create a big as lens as you want on Earth, at least, because you need gravity for it.
Fourth step is the last step that Newton talks about. Finally, what happens after enough time is that the water's spinning, the bucket's spinning, but as the cord begins to twist the other direction, eventually this bucket is going to come to a stop. Okay, so like this. So the cord gets retwisted, I guess, but in the opposite direction, right? As the bucket kind of overshoots like this, and eventually
the bucket overshoots with the water.
The bucket is going to come to a stop. So at this moment in time, the bucket is at rest with respect to the room. Okay, but at the moment the bucket comes to rest, the water is still going to be spinning, at least for a little while, right? So the water in this case is spinning with respect to the room still, at least for a little while. Eventually it'll probably come to a stop. But at this moment that I'm drawing, the water is still spinning with respect to the room. And hence, if the bucket is at rest compared to the room, but the water is spinning compared to the room, that means the water is spinning with respect to the bucket, right? And finally, if you were to look down at the surface of the water, you would see that the surface of the water is curved still. It's curved, just like here. So let me draw the water. So the bucket's at rest, but the water is still spinning around, and the surface of the water is going to be curved compared, it's going to look curved from the top, right? Okay, so this is the thought experiment that Newton goes through. Now, who cares? Why are we talking about this spinning bucket? What's the point of this entire thought experiment that Newton runs us through? So let me ask this question. What's the point? And more particularly, here's the thing that's of interest. What determines if the surface of the water is curved? What determines if the water surface is curved? After all, in some cases, the water surface is curved, and in some cases, the water surface is flat. So there must be something causing the surface of the water to curve. So let's consider one possible answer. Is it the motion of the...
So the answer is that the water is moving. Let me see. Rover da Vinci.
That's my name.
Hover da Vinci. Hover da Vinci. Da Vinci. I'm watching YouTube. I'm watching a... Oh, that's not the one.
Do Grabby aliens solve the Fermi paradox?
Here, this is the link to it. You want to join me on StreamYard so we can watch YouTube together?
No, I'm okay.
Then how can we? Then we're gonna have to talk without watching stuff together.
I'll just watch in the.
So I'm watching the bucket. If you want to figure out Newton's spinning bucket experiment, like I think I can easily solve it. I don't even see the issue, but it's a famous paradox that Newton couldn't solve. So give it a shot, and we'll talk after.
Sure.
Okay. So I'm gonna talk while watching it in on the other tab. You can mute me if you want. All right. So the answer is, I'm going to give the answer. So the answer is, if you look from the top, like this. Yeah, I'm going to need to draw it over here. Launch.
Oh, what happened? Where'd it go?
Where did it go?
Oh, wait, where'd it go?
What is going on?
What?
No. I'm just reading emails. This is so
you
weird.
should make an email paradox.
The email paradox. All right, let me see.
I wonder if there is like a TCP/IP email paradox,
Email is not. Email sits on top of TCP/IP. It's a separate email. It's a separate email protocol.
Yeah, but like if the packages are being acknowledged, how do you know that acknowledgement is legitimate? Should you acknowledge the acknowledgement of the acknowledgement when you're doing the internet handshake?
That's the too general problem.
Fuck, you're right. God damn, I knew it was some other kind of problem. You're right, that's not really a problem.
What, you didn't... right.
I forgot about the too general problem.
Right, there's never a perfect solution to any handshake.
Yeah.
All right, so this is going to be the bucket. Newton's bucket. Newton's...
Aren't there apps now that'll just generate the buckets for you when you type it in?
You want to see the solution?
Sure.
Before you see the question, I'll tell you the question. You want to see it on my stream, or you want to see it on my... Where do you want to see it?
I'm just looking at your screen right now. I'm looking at it on YouTube.
You're watching me on YouTube?
Yeah.
Okay. All right, so the solution to the bucket paradox is as such that let's look at the bucket from the top, right? I don't know why they don't do that. So the bucket paradox is a spinning bucket with water. How does the bucket know that it's spinning?
What?
Yeah. I mean, how does the bucket know that it's spinning? Like, there's no absolute motion, right? You cannot feel that you're moving, right? Right now, we're on Earth, moving around the sun. There's no way you can know that.
No, of course. I agree.
Right? If I close you inside your room, I don't let you look outside of your
I
room.
can tell if the Earth is spinning like gazillion kilometers an hour.
Right. It's actually 30 kilometers a second with respect around the sun. But there's no way you could detect it, as far as I know. Even with equipment in your room, whatever equipment you want, you'll not detect this motion. And also, the sun is spinning around the galaxy, and the galaxy is expanding with the universe. There's no way you could know these things without looking out your window with telescopes and with equipment. There's no way you could know
to
that.
do then you just play you spin me right round,
Right. So, and as far as you know, you might be in a spaceship accelerating upwards if you couldn't look outside. So, all right, that's a given. So absolute motion is undetectable. Like if I put you in space and you're floating in space in an empty universe, so you couldn't know if you're moving or you're stationary. It's not even defined. Right.
Yeah, exactly.
If you're
There's
all
not them interacting with it, right?
exactly. If you're all alone in the universe, how could you know what does it mean to move or to stop? Like, what does it mean? So that's the assumption of the story. That's the assumption. Okay. So if that's a given, so but if I spin you, you could tell that
round,
right?
like a record, baby. Round.
If I spin you around yourself, you would feel your arms flailing. You would feel your arms being pulled apart. Right? If I spin you around yourself, you would feel it.
You have what is that, like, I don't know, kind of like centrifugal force or some shit.
Right. So the question is, why can you feel? Well, so the answer. So some people said no. If the universe were empty, you wouldn't feel it, because the reason why you feel it right now, if you spin around yourself, is because the universe is stationary, and there's something about the universe that is sending you a signal. That's the claim. The claim is that in an empty universe, you would not know that you're spinning. There is no definition to spinning. So this, well, the answer is we don't know. The answer is we don't know. Okay, so I mean, at this point, I'd want to watch the video, so because I need to know what the paradox is. I didn't yet finish watching the paradox, so either you watch it separately or I'll watch it separately. It's up to you. I'm gonna watch it. I'm like almost done, so you can think about it. I just you can watch it on my stream, right? You can just watch it on my stream. I'm gonna stream it.
The water with respect to the bucket.
So he explained the paradox of the bucket spinning. Basically, he put a twisted wire, the bucket in the water was stopped, and he let go, and the bucket started spinning, but the water didn't. Then they both were spinning, and then it got recoiled, retwisted, and the bucket stopped spinning, but the water keeps on spinning. All right. Now he's asking, what determines if the water, this is not the thought experiment. This is the question, the paradox question. What determines if the water surface is curved? Right? So when the water is spinning, it's curved, water is spinning, it's curved, but here the water is not spinning, it's not curved. So what determines if the water is curved? Answer 1. Is it?
So is it the relative motion of the water with respect to the bucket? So if in other words, is the water?
Okay.
Is the water spinning compared to
is it because the water is spinning with respect to the bucket? Well, here the water is spinning with respect to the bucket and it's not curved, so that can't be it.
bucket? If it is, it's curved. If it's not, it isn't. Would that be a good explanation? Well, in this case, the water is at rest with respect to the bucket. So in this case right here, and in this case right here, in the third case, it's at rest compared to the bucket and it's curved. And in this case, it's spinning compared to the bucket and it's curved. So here, in these two cases, in one it's at rest and in one it's spinning compared to the bucket, but they're both curved, right? And going back to this case, here it's at rest compared to the bucket and here it's spinning compared to the bucket, and in both cases it's flat. So it seems like its motion compared to the bucket will not determine.
He's going to put an X, a red X.
And whether or not it's curved. Okay, so no, that doesn't explain whether or not it's going to be curved. Okay, what about maybe it's its motion with respect to the room?
A2.
Okay, so answer 2. It's maybe is it the motion of the water with respect to the room? Maybe that's what's causing the.
Let's see. So here the water is not spinning with respect to the room. Here it is spinning with respect to the room. Well, when it's spinning with respect to the room, right here it's spinning with respect to the room. Yeah, I mean, it looks like spinning with respect to the room, which means the rest of the universe.
Surface to curve. So in other words, was it sort of the walls of a cathedral or this big room around it that is causing it to curve? Well, I mean, how can walls or roof or whatever cause something to curve? Newton is very skeptical of this idea that it's actually the walls themselves or the motion compared to the walls that's causing it to curve. So he says, no, that's not going to be possible. But maybe it's the motion compared to like the floor.
The universe.
Or maybe something even bigger, like the earth itself. So maybe it's the motion of the water with respect to something huge, like the earth. It's spinning compared to the earth itself that causes it to curve. Is that possible? Well, no, says Newton. There's no reason that it's spinning relative to the earth would cause it to curve.
If you keep saying there's no reason, then you might as well say there's no reason. Oh, so he's going to end up saying, well, there's no reason. If there's no reason, then why is it curved?
That doesn't seem to make sense. Maybe it is the spinning of the object with respect to some physical object that causes it to curve. So, or any physical object. And Newton says, no, it's not the spinning of this water compared to a physical object that is causing it to curve. Newton says what's causing this water to curve is the spinning of the bucket with respect, or the spinning of the water with respect to absolute space. So he says the reason the water is curved, the water's surface is curved.
That's interesting. I mean, obviously I think he's wrong. I have my solution, but you tell me your solution.
Is because it is true.
Wait, Da Vinci, do you understand the question so far? The last one is maybe it's absolute space. Space itself, like when you spin relative to space itself, there is an absolute space. And spinning relative to absolute space is what causes the water to curve.
Truly spinning. It is truly spinning. And by that,
so there is true spinning. There's absolute spinning.
We mean it is spinning in absolute space, or with respect to this absolute reference frame. So spinning with respect to absolute space. That is, it is truly spinning. Because whether something is...
So my answer, that's wrong also. Everything is wrong. Let's see if he gets my answer, and you tell me what you think.
Really spinning or not is going to determine whether it's curved, not whether it's spinning with respect to some particular physical object. The very fact that the water is curved, that the surface of the water is curved, says Newton, is evidence of an absolute frame of reference, that is, of absolute space.
No, I disagree. You don't need that.
So although we cannot detect...
Even though I do believe in absolute space, but you don't need absolute space to answer this question.
Absolute linear motion, says Newton, through this absolute space, we can detect absolute rotational motion in space. And how do we know whether something is truly absolutely spinning? Well, there's these sort of forces of recession from the axis about which it's rotating. So if we think of this string right here as an axis of rotation, if it's spinning around this axis in absolute space, there's going to be these forces that try to make it recede from the axis that causes the surface of the water to curve. So this is Newton's proof. And he would say this is empirical. Or empirical or...
This is empirical.
Observational, experimental proof of the existence of absolute space. Not just measuring space compared to physical objects, but the existence of an absolute space. I should mention at this point that Einstein is going to have to address this spinning bucket thought experiment. He spends a lot of time worrying about this experiment because Einstein does not believe that there is a such thing as absolute space. He thinks that all spatial measurements are relative. It's nonsense to talk about absolute space. So somehow he must take very seriously the spinning bucket experiment of Newton.
Okay. So that's the question. It's unresolved. No one has an answer. What's your answer?
it try to make it recede from the axis that causes.
Yeah, what's causing the curvature of the water? How does the water know that it's spinning? Like if I spin you, how do you know that you're spinning? Is it the No. Even you, if I spin you, forget about the bucket. How do you know that you're spinning? Or you feel your arms being pulled apart. Why do you feel what's causing your arms to feel like they're being pulled apart? Like in an but in it let's go back to an empty let's go back to an empty universe. In an empty universe, what's the difference, right? You don't know if you're moving or you're stationary. But you except for if you're spinning. Would you That's the question. Would you be able to define spinning in an empty universe? So you wouldn't feel your arms but let's say I give you two jet engines, two rocket engines, and you put one in your right hand or one in your left hand, and you point them in opposite directions, and you fire the rocket engines, and you start spinning. Would you feel it? Or would it be meaningless? The question is, do you need a reference point, or is spinning relative to yourself? Good. Would you say that basically it's your right hand relative to your left hand? So would you feel the spinning? So how do you explain it? I mean, Newton couldn't figure this out. So he had to come up with absolute space, which is nonsense. I believe in absolute space, but this is not. No, you're in space. You're outside in a spacesuit, in space, in an empty universe. You just have two rocket engines, one in your left hand, one in your right hand, and you turn them both on in opposite directions. And you start. Do you feel that you are starting to spin, or do you not feel the spin in an empty universe? Do you need? But the question is, that's the question. Would you be able to feel the spin in an empty universe? Do you need to see? But I don't know if you're spinning. What's the definition of spinning if you can't see the universe? There is no universe to see. So is spinning, would you feel that you're spinning? Would you feel your arms torn apart as you are spinning faster and faster and faster and faster and faster and faster? Or are your arms going to get torn apart? In an empty universe. But how do you know that you're spinning? There's no reference. What's the definition of? But you think your intuition is that you would feel that you're spinning. Wait, nobody can hear you. Oh, I forgot nobody. Oh, you okay? Come on, you gotta join my StreamYard because this is gonna happen again and again because they're gonna hear me talking to myself.
I'm not even real. I'm just your other personality.
All right, come on,
How
join
you
me.
doing about?
Please do me a favor. Join me on StreamYard. Otherwise, it's gonna happen again and again.
I don't know. I don't know about the thingy though.
Are you gonna join me?
Join you where? In the
StreamYard.
StreamYard?
You don't have to.
I'll
I just
think about it.
I just want to avoid this. I don't want to ruin the stream with people sitting there and they
Is
can't
anybody listening to the stream? How many people are watching the stream right now?
One person is watching, and that's you. But in the future, people always there's always many people watching. Like every stream gets some streams like get over 100 views, and in time, hopefully, people will go back and watch these videos, and I don't want them to get frustrated. Like I'm making content for the future. Like part of it is me showing my progress in my research. Okay, I don't want to waste time. Let's do you see, okay, you see my stream, right? You see my whiteboard? Oh, you join me? Okay.
Me?
Spinning astronaut, very good. Good name. All right, let's get back to business. So, here's the bucket from a top view, or
Okay.
whatever, or you from a top view, and you're spinning. So even if, here's the solution, it's really very simple. You want to try and give it a last shot before I tell you my solution?
I just don't want to put out the brain power to like think about it. I mean, I don't know what's determining the curvature and the surface of the water. I feel like it's I don't know.
Okay. Look, Newton didn't know, Mach didn't know. I don't think Einstein resolved it either. Did Einstein resolve it? Let me check. So Ernst Mach is like Einstein's predecessor or whatever. Getting rid of absolute space, you've been inertial framed. That's Newton. Deriving Dirac. What is gravity? Let's look for solution to the bucket, or Einstein's solution to the bucket paradox. I think 60 symbols has, Einstein's ladder, that's no good. Einstein's pole, no. Einstein's rock, no. Einstein's gravity, no. Puzzling Einstein EPR, no. Newton versus Mach. Oh, dialect.
Another parameter.
Okay, that would be.
Which aspects? It's a debate that's raged for millennia. Which aspects of our reality are absolute and which are merely relative? When it comes to the concept of motion, two physicists held opposing views, and to resolve the differences in their philosophies, they invoked a simple thought experiment that involved, well, a bucket and some water. But does this experiment really prove that motion has absolute meaning, or does it actually demonstrate the opposite, that motion is just a relative construct? Today, we'll pit these two thinkers against one another to find out. This is Dialect with Newton versus Mach, the bucket experiment. When Newton introduced his groundbreaking theories in the late 1600s, he framed them against a mathematical background that contained three absolutes: time, space, and motion.
Do you want to watch it, or do you want me to just give you the answer?
I don't mind. Whatever you think.
I'll give you my answer. I don't care anymore because it looks trivial to me. You tell me how trivial you think it is. Anyway, so we both agree that even if there is no absolute space, let's say you're alone. Here is you. You are all alone in space, in a spacesuit, okay? All alone. And you don't know if you're moving, you're not moving. All right. But then you see me flying from a distance. You see me coming basically in your direction, passing by you. Okay? I'm zooming past you. So you don't know if you're moving and I'm stationary, or you're stationary, I'm moving. You don't know who's moving, who's stationary. All you know is relative motion, right?
Yeah.
Okay. Now imagine as I pass by you, you throw out a tether and I hold on to it and I grab it. So it doesn't matter who's moving, who's not. What's for sure is now we're going to start spinning round and round, right? Because of my linear momentum, right? There's going to be, let's say we are of equal masses. and that's the center between our masses. So because of symmetry, we're just going to spin around each other, and we're going to feel this spin because, right, let's say instead I was aiming straight at you and I impacted on you. Everybody agrees that you would feel that. We would both feel the impact. It's not like we need the universe to collide and feel the collision. Right? No one says that in an empty universe we don't have linear momentum. Right?
Yeah.
Right? This is relative momentum. This is relative speed, relative momentum. Everything is relative. So this is the same. This is just the collision is off center, but we're still going to. There's no reason why we wouldn't feel going round and round. So much so that we can always let go of each other, and we would, as far as we're both concerned, we would fly away from each other like before. So before you're about to zoom away, I can hold on to you and we would spin together, and then I let go. And because you conserve momentum and I conserve momentum, so we're gonna fly apart and tangentially to the circle of motion. And that's the answer. The answer is I don't need absolute space in order to feel spinning. It's got nothing to do with absolute space. It's relative motion. And that's the bucket. So
yeah, that's how I'm imagining. Like, if you stick a stick in a tin of paint and you just stir the paint, right? Like it's relative to the paint will be curved relative to the paint.
Yeah, but the question is, a bucket in empty space, what will it do? Will it curve? Can you curve the bucket in empty space? Can you curve the water? So my solution is that this molecule of water and this molecule of water, it's basically the same as me and you. This molecule of water simply has linear momentum, and this droplet of water has linear momentum, and this droplet of water has linear momentum, and the water between them, right? Basically, a sort of a vacuum is created. Well, this experiment cannot be conducted in empty space, by the way. The buckets cannot be spun. We wouldn't get a curve because in empty space,
the water wouldn't hold to the bottom of the bucket, right? 'Cause there's no gravity.
Exactly. There's no bottom to the bucket. Yeah. So it would have to be a little bit different. Like the bucket, we would first need to put it in a spaceship with engines and point the fire down. So the bucket would be accelerating upwards. That would be the first step and then we would tether it to the ceiling and start the experiment. Okay, good enough. So as we're doing that, as we spin the bucket, the water will curve. I predict the water will curve in an empty universe. You don't need the universe to curve the water because this droplet wants to go straight when you spin it, and this droplet wants to go straight when you spin it. So as basically they right, they feel like they're being pulled apart. That's exactly what's going on when you're spinning on Earth. You have your arms apart. This arm just wants to go straight, and this arm just wants to go straight. And you're trying to change the direction of the arm, right? You're trying to change the direction of the arm to keep it in a circle. So you're trying to change the direction. That's the tethering, and the droplet basically wants to. Its inertia is as if it wants to. It's as if it wants to resist, and it's not that it wants to resist. This is a fake force. It just wants to go straight, and you want to move it to the left. So you're applying force to it, but it is moving up against the walls of the bucket because it wants to keep going straight. So it climbs the bucket. Anyway, and that's it. I mean, it's just relative motion. It's literally relative motion. This is simple relative motion, and everybody's losing their minds over it as if there's something interesting.
Time.
Okay.
Appear essentially indistinguishable, and then show that even in these instances, such telltale differences can always still be found. The problem then is that for the bucket experiment to fulfill this criteria, that is, for there to be a state of rest for the system which is only apparent, the bucket is required to inhabit a gravitational field. Thus, to make his case that true motion can always be locally distinguished within a system, Newton is actually forced to invoke a nearby mass external to that system, meaning his experiment could
you can be on a spaceship.
Not be reproduced in the absence of external matter. Since this falls more in line with Mach's argument than it does with Newton's, we're crowning Mach the winner of this first round. Likely realizing the bucket experiment was a little too contextual, Newton in his writings offers up a second experiment. Take two globes attached to a cord.
Forget it. Oh, that's literally the same.
And spin them around in a circle about their center of mass. Then, by investigating the tension produced in these cords, one could determine the quantity and direction of the circular motion, considered even in an immense vacuum where there was nothing external or sensible with which the globes could be compared.
Okay, sounds like my solution.
Now this experiment, unlike the bucket one, has the benefit of being able to be reproduced in the absence of external matter. But in keeping with the bucket experiment, it offers two states of apparent rest, along with a theoretical way to measure the difference between them. To see how this measurement could occur, it might be easier for us to envision our two masses as attached by a spring rather than a cord. As the masses rotate, centrifugal forces push them outwards, stretching the spring.
Well, that's literally my thought experiment.
Stretched spring therefore indicates absolute rotation, and by measuring how much the spring has stretched, one can determine the exact magnitude of force causing the rotation. With this simple, definitive-seeming argument,
that's basically called an accelerometer.
Newton claims the title as our second round winner, establishing a concept of absolute motion that could be empirically verified even in the absence of all other matter in the universe.
So that's relative motion, it's not absolute. We're having a problem with definitions. I don't know. Okay, forget it. Let's watch something else. So let's watch Sabine Hossenfelder.
One of the most surprising discoveries I've seen in my lifetime was dark energy. It was so surprising that the first time I attended a seminar.
Do you know what is dark energy?
It's the opposite of light energy.
Yeah. It's that the universe is flying apart. The universe is ripping itself apart. The universe is expanding and it's accelerating the expansion. And we don't know why. Okay?
Okay.
That's a given. That's what we know. That like you heard of the redshift? You heard that galaxies redshift, and the farther a galaxy is, the more it redshifts. So we know the universe is expanding. But in 1998 they discovered that the expansion is accelerating. So dark energy is whatever is causing the expansion to accelerate. Did you know that the expansion is accelerating?
Yeah. Yeah, I think someone mentioned it. Yeah.
Okay.
Did they know the speed that it's accelerating at? Or like what speed it's traveling at?
It's accelerating. I forgot the value. Well, I don't know. I was actually watching a video that he went through the numbers. Really simple. We can do that after. It's accelerating by some measure. Let's watch what she says.
About it. Everyone was sure this was a measurement error. It wasn't. Dark energy seems to be real, but physicists have no idea what it's made of. In a recent paper, two physicists now claim that it isn't made of anything, but instead a consequence of our universe being holographic. Let's have a look. Genuinely new idea.
So in my opinion, that's nonsensical. I'll give you, that's my opinion. The holographic principle is complete nonsense.
Ideas are rare, but the idea that the universe and everything in it is really a sort of hologram is such a rare new idea.
So they claim that this universe is just a hologram.
Yeah, it's called the holographic.
Like you pay people to resolve problems in physics and they come up with, this universe is just a hologram.
Principle. It was put forward in the early 1990s by Gerard Toft and Lenny Susskind, one of whom has won a Nobel Prize and the other was recent.
Lenny Susskind, I like him. He's a cool guy, but when it comes to the holographic principle, that's nonsense.
Called An Asshole by Eric Weinstein.
This is basically
Yeah, she's good friends with Eric Weinstein more than Lenny Susskind, because Lenny Susskind is a string theorist, so she's against Lenny. So it's like tribes. I think he's a Looney Tune. This guy, she's half loony. They're all loony,
Yeah,
each
no,
in their own
Weinstein
way.
and his brother are out there. Yeah.
They're all conspiracy theorists.
Yeah.
She's a conspiracy theorist because she believes in global warming. He's a conspiracy theorist because he believes in his mathematical universe. His brother is a conspiracy theorist because he thinks that someone created the schmovid epidemic and the jabs and on purpose destroyed the
Yeah.
military. Anyway, everybody's a loony. They're all loonies. No one here is
I
normal.
agree.
And Lenny Susskind believes in string theory and the holographic principle. So no one here lacks looniness. All right.
The attempt to take a school massacre and plead to a parking ticket. And no, I think that the prosecution should decline the offer from the good Dr. Susskind and say, no, you have 40 years of the destruction of your colleagues to answer for. You've chosen to be, words family, an asshole.
According to my new idea, podcasts are a sort of hologram too.
Yeah, Eric Weinstein, he used to be a mathematician in Yale or Harvard, and he was forced to leave, or he left and he became like a quant. I think he's really rich. He's got to be really rich because he was a mathematician and he went into finance. So you can't be poor. But he's unhappy that he's not an academic and he's after the academics. He just hate academics even more than I do.
They actually happen in an entirely different dimension.
As well.
His brother's a evolutionary biologist. I listened to the Dark Horse podcast with the other Weinstein. I don't know their names. And I used to listen to all the episodes with his wife, but just too much conspiracy. Like
Yeah, he kept
at one
taking
point,
research papers that were not peer reviewed and then seeing that they're published and peer reviewed when they're just like preliminary papers, and he would jump to all these conclusions. It was really weird. Like,
no, I'm fine with that. No, I don't have a problem. It's fine. That's not the reason he's a loony. He's a loony because he debated people and they said to him, "Listen, we agree Schmovid was nonsense, but there was no conspiracy." And he said, "No, there is a conspiracy." Like he was hinting that the Chinese or the Russians, they were behind the jab. That's what he was hinting, that an enemy, he doesn't know who. He kept saying, "I don't know who the enemy is. Something is the enemy, and something is conspiring to destroy the military." Like if I wanted to destroy America, I would first destroy the military, and if I wanted to destroy the military, I would create the Schmovid, and I would create the jab as if for the Schmovid, and they're coming after us. Like total loon.
yeah, but he was using research papers to also back up these kind of wacky theories.
No.
As well.
Everything else I agree with. Everything else he ever said, I agree with, except for that somebody's trying to destroy the U.S. through the jab.
Okay.
And people debated him. People told him, "Look, we agree with everything you're saying, except for the conspiracy part. Yes, it's destroying the U.S., but you don't have to have somebody planning this, and you don't have to have anybody planning to destroy the U.S. while somebody is destroying the U.S. People are destroying the U.S., yes, but you don't have to have a conspiracy to destroy the U.S. It could happen just, by sheer by sheer stupidity." But he said, no, this is completely planned. Anyway, Looney Tune.
If the holographic principle was right, it'd mean that everything which goes on inside a volume of space can be entirely described by what goes on at the boundary of that space. It's like the universe is a box of cereals, one that doesn't only have the ingredients listed on the outside, but also how the nuts move around if you shake the box. The idea came out of black hole research because it seems that the amount of information that a black hole can store doesn't scale with its volume, but rather with the surface area. Toft and Susskind then said, well, what if that's true, not just for black holes, but for every volume, cereal boxes, planets, the entire universe? That's the holographic principle. It's a bold and quite audacious.
Is it true? So the claim is you can all the information that is stored inside me is available outside me. You should be able to get all the information that's inside me by looking at me. Do you understand?
Yeah.
Do you agree?
It depends how they were looking at you. Like, I don't know how
So
accurate that would be. Like, I mean, it's like if we did an X-ray, like we could see what your bones were doing. If we
right.
did an
So
MRI, we could see. You know what I mean? It depends on how they're looking at you, I guess.
I guess.
I'd
I
say-
mean, I think that's what he's saying. He's saying that all the information is available and forever will be available. And okay, so is the universe a hologram because you can X-ray me, so I'm a hologram? What? Because let's say all the information is available without peering literally physically into me. You can figure everything out about my internals from outside. So therefore I'm a hologram? Are you insane? Like, these people are just insane.
I guess what he's getting at is that are we actually looking at the thing, or are we actually looking at the hologram? That's the
He
question he's asking.
claims the universe is a hologram. It has no internals. It's just a wrapper. You don't.
Right.
So he claims because all the information what's inside me is available from outside, therefore I don't need to exist on the inside. As far as he's concerned, I'm a pure wrapper because all the information is available from the outside like a hologram, which is to me complete lunacy. Like, these people are yeah.
I'm just hearing it differently. I'm kind of hearing that, you know, if we look at like an MRI or an X-ray, that the X-ray is the hologram, and that you're the real thing.
No. He's
Am I
saying
misunderstanding it?
yes. He's saying the universe is a hologram. The universe has no internals because all the information of the universe is available from outside the universe. Therefore, the universe is empty. We are two-dimensional creatures. We're not three-dimensional. We have no depth.
Okay, maybe I misunderstand it on that.
Well, what else could the universe as a hologram be?
Well,
I mean, you heard what she said. All the information of the cereal box is available from outside of the cereal box.
Colleagues to answer for. You've chosen to be Ford's family an asshole.
According to
I'm rerunning the last sentences.
my new idea, podcasts are a sort of hologram too. They actually happen in an entirely different dimension. If the holographic principle was right, it'd mean that everything which goes on inside a volume of space can be entirely described by what goes on at the boundary of that space. It's like the universe is a box of cereals, one that doesn't only have the ingredients listed on the outside, but also how the nuts move around if you shake the box. The idea came out of black hole research because it seems that the amount of information that a black hole can store doesn't scale with its volume, but rather with the surface area. Toft and Suskind then said, well, what if that's true, not just for black holes, but for every volume, cereal boxes, planets, the entire universe? That's the holographic principle. It's a bold and quite...
I hate it when you eat cereal and it drips on your chin.
You have to invent a new type of like spoon or something for like.
Yeah.
It's really bad when you have a beard, you know.
Oh.
Because if it was true, this would mean that the information about what goes on inside the universe is highly compressible. You don't need to track what's going on in some part of three-dimensional space. All you need to know is what's going on at the surface of that space. By the way, this video comes with a quiz that lets you check how much you remember. What does any of this have to do with dark energy? Dark energy is whatever's causing the expansion of the universe to get faster. Astrophysicists have measured how the expansion is speeding up, and that gives us a value for dark energy. The curious thing is that this value is roughly the inverse of the square of the radius of the visible universe. In other words, it's proportional to 1 over the surface area. Surface area. Coincidence? Yes, it could just be coincidence, or maybe dark energy is actually a consequence of the finite size of the observable universe, and it comes from the boundary. You see, in our mathematics, the universe is infinitely large, but we can only observe part of it. That's because the universe has only been around for about 14 billion years, and we can only see galaxies whose light had time to reach us. This is why the universe has what's called cosmological horizon, a limit beyond which we can't see. The idea of holographic dark energy now has it that this boundary, the cosmological horizon, gives an energy to empty space because it cuts through quantum fluctuations so that they can no longer average out to zero. The larger the volume, the less you notice that. The resulting energy of empty space is proportional to the inverse of the size of the boundary. And this energy behaves kind of like you expect dark energy to behave. It's not constant, as is often assumed.
So it's proportional to the inverse of the what? How? It's I don't get that the inverse to the proportional to the inverse of the something. Dark energy is proportional to 1 over the surface area. Like, if it were proportional to the surface area, proportional to 1 over? So how does that help you?
And that gives us a value for dark energy. The curious thing is that this value is roughly the inverse of the square of the radius of the visible universe.
The inverse of the square. Wait.
And that gives us a value for dark energy. The curious thing is that this.
Let me turn on comment.
What is the inverse of a square?
She said square.
Value is roughly the inverse of the square of the radius.
Oh, the square of the radius. Wait, what? The square of the radius? The square of the radius is
the square of the radius of the visible universe.
The square of the radius? That's the volume. The square of the radius is proportional to the volume. That's not the surface area. What is she talking about? Oh, no, the surface of a sphere is the square of the radius, and the volume of a sphere is the cube of the radius. Right? It has to be.
Right, yeah, right.
I mean, it has to be, right. So, right. So it's 1
what does
over.
The word inverse mean there? Sorry, is that
inverse
like...
means 1 over. Inverse just means one
yeah.
over. So the bigger the surface area, the smaller the dark energy. Okay.
Radius of the visible universe. In other words, it's proportional to 1 over the surface area. Surface area. Coincidence? Yes, it could just be coincidence, or maybe that.
So she's like, she's making fun of it. It could be just coincidence.
Energy is actually a consequence of the finite size of the observable universe, and it comes from the boundary. You see, in our mathematics, the universe is infinitely large, but we can only observe part of it. That's because the universe has only been around for about 14 billion years.
I mean, obviously, the universe cannot be infinite because nothing in physics can be infinite. Well, you could say physics itself could be infinite, but I don't see it. I mean, nothing we've observed, nothing we can imagine is infinite. So I don't know. But mathematically, the universe is infinite. Wait, what just happened?
No, I just left Discord. Can you still hear me?
Oh, what?
Can you hear me?
Yeah, I can hear you, sure.
Okay, it's just because
And we can only see galaxies.
What?
I was getting an echo. I had the two open.
Oh, okay. All right.
Is infinitely large, but we can only observe part of it. That's because the universe has only been around for about 14 billion years, and we can only see galaxies whose light had time to reach us. This is why the universe has what's called a cosmological horizon, a limit beyond which we can't see. The idea of holographic dark energy now has it that this boundary, the cosmological horizon, gives an energy to empty space because it cuts through quantum fluctuations so that they can no longer average out to zero. The larger.
What? So I don't think dark energy has anything to do with quantum fluctuations because we know the numbers don't work out. So we know the quantum fluctuations cannot have anything to do with dark energy because if they did, we would get much bigger dark energy. So I don't know what she's talking about in that regard. Also, I don't understand. I don't see the relationship, why it should be related.
Cosmological horizon, a limit beyond which we can't see. The idea of holographic dark energy now has it that this boundary, the cosmological horizon, gives an energy to empty space because it cuts through quantum fluctuations so that they can no longer average out to zero. The larger the volume, the less you notice that. The resulting energy of empty space is proportional to the inverse of the size of the boundary. And this energy behaves kind of like you expect dark energy to behave. It's not.
So, they're saying that's the holographic principle. You see that it's because of the surface area. So it's basically because of the holographic principle. But why is it 1 over? So the bigger it is, the less you notice it. All right, whatever.
It's not constant.
I don't see the cause and effect.
As is often assumed, because the size of the universe increases, but it changes slowly enough so that it fits the data okay-ish. This idea isn't new, it's been around for 20 years or so, it's just that physicists thought it doesn't work, because a vacuum filled with such holographic dark energy wouldn't be stable. This means basically if you have some small random change.
I don't care. Do you care?
About the stability of...
No, about this entire discussion, I don't care. I mean, I'm lost. I don't see I like simple things. Like once I don't understand something, I give it a few more seconds and then I just let go.
Mm-hmm. Yeah.
Do you want to watch it?
If you want to, I don't mind.
No.
Not like super
I don't.
engrossed in it or anything.
Right, I'm not either. All right, let's try. What is gravity?
Gravity.
What goes on?
What?
I said gravity.
Oh.
Must come down. We've heard that old saying many times, but as it turns out, gravity isn't quite so simple. Hi, I'm Rich Burnett for Wondrium. In this episode of Perspectives, 4 experts discuss what we know about gravity, as well as some of the things we're still trying to figure out. We begin now with some of the earliest theories of gravity by a man often referred to as the first scientist, Aristotle. Enjoy.
In the 4th century BC, Aristotle tried to describe gravity as being the nature of matter.
That's Don Lincoln.
His theory.
That's Don Lincoln, one of my favorite physicists. He's not a theoretical. He's a experimental.
Oh, experimental.
He's an experimentalist. Yeah.
Revolved around a geocentric model, one in which the Earth was in the center of the universe. The natural location for all matter was the center. Hence, when things fell, it was explained simply as matter trying to get to its natural location. Other things had other natural locations. Fire, for example, was trying to reach the heavens, which is why flames rise. We're talking about gravity, so let's stick with matter. Aristotle's theory of what we might call terrestrial gravity, that is to say, the behavior of gravity here on Earth, was simply an instance of objects trying to get to their natural place. The sky was a different thing. The sky was governed by the gods.
I think he lost weight since then. This is like many years ago. I think he used to have a little tummy.
The sun, the moon, the planets, comets, and stars were each embedded in one of a series of concentric spheres centered on the Earth. The motion of the heavenly bodies was caused by the rotation of the spheres, with the rotation made possible by the intervention of individual gods. There was no concept of what we might call celestial gravity, which is, of course, the gravity of the heavens. So Aristotle's ideas were developed in 400 BC, give or take. Now, did those evolve over time? That's a long story, beyond what we can describe here, but it involves some of the great minds of all times. Greek astronomer Ptolemy postulated the Earth was at the center of the universe, but imagined something a little more complicated than Aristotle's spheres. In 1543, Polish astronomer Copernicus shook up the astronomical community when he postulated that the sun and not the Earth was at the center of the universe. The Catholic Church was not at all happy with this idea, but it stood the test of time. German astronomer Johannes Kepler made additional contributions when he used precise astronomical observations made by his mentor, Tycho Brahe, to determine that he...
I thought it's with a G. Everybody keeps telling me it's with a G. Tycho. All right.
Could explain the data if the planets orbited the sun in elliptical orbits. He also was able to work out the speed of the various planets and found that they moved at different speeds while they orbited. The penultimate hero in our study of gravity is Italian astronomer and physicist Galileo Galilei. He studied both the behavior of matter here on Earth and also in the heavens. Legend has it that Galileo dropped heavy and light objects from the Leaning Tower of Pisa and demonstrated that they fell at the same rate. This story is probably apocryphal. He probably drew his conclusions by rolling objects down ramps. But either way, he was right. Galileo also studied the heavens and used a newfangled telescope, which he didn't invent, but did lead the way in using it in astronomy. He found that Jupiter has moons, which weighed heavily towards the idea of the sun and not the Earth as being the center of the universe. But again, there was no unifying explanation between how things fell on Earth and how objects moved in the sky. It was British polymath Sir Isaac Newton who made the truly crucial advance. Newton was one of the smartest and most scientifically influential people of all times. The number of things he was able to explain is simply staggering. However, from the gravity point of view, what he did was come up with a model that successfully demonstrated that celestial and terrestrial gravity were one and the same. We call his gravity model Newton's law of universal gravity for just that reason. He worked out the idea that two objects would feel a mutual gravitational force.
He unified celestial gravity with Earth gravity.
Yeah, terrestrial.
Yeah.
Right. So this is the force of attraction between two massive bodies.
So the two objects and the distance between them. Well, the distance squared, actually.
That's what she said.
What?
You said there were two massive bodies, and I said that's what she said.
Anyway, this is Sean Carroll, California. I don't know if he's still at Caltech. He's now a professor of philosophy or philosophy of science.
As successful as it is, it's also quite mysterious. Let me emphasize, it is very successful. Newton's law of gravity is all you need to get to the moon and back. If you want to travel around the solar system, you want to figure out how the planets move, except for the tiny little exception of Mercury, which is closest to the sun, where we need...
He's thin. But these are I think these are very old videos. I think this is like 10 years old.
General relativity, Einstein's theory of gravity. But for the rest of the solar system, Newton's theory of gravity is very good. But it's mysterious, and Newton himself recognized this. The reason why it's mysterious is, how do the planets know how strong the gravitational force is supposed to be? It's as if gravity is reaching out over empty space with nothing in between, from the sun to the planets, and saying, here's the force that is acting on you. Newton was very bothered by this. This is called action at a distance, and Newton himself didn't like it. If you read his masterwork, Principia Mathematica, Newton himself will say, I don't know why there's this action at a distance involved with gravity. I leave it to future generations to finally figure it out. But in fact, it didn't take very long. Not long after Newton, around the year 1800, a French mathematician and physicist named Pierre-Simon Laplace came up with a slightly different theory of gravity. Now, Laplace's theory of gravity is not one that you may have ever heard of, because basically it's exactly the same as Newton's theory in all of its experimental predictions. Once you have Newton's inverse square law, Laplace is not giving you a different law, he's giving you a different way to get the same law. And what Laplace says is, instead of just thinking of a gravitational force, think of a field pervading space. Think of a number at every point in space, which Laplace called the gravitational potential field. And in Laplace's version of gravity, he replaces Newton's equations with equations for this gravitational potential field. And he says two things. Number one, a big massive object warps the field. By pushing on the field, it changes its value. And then number two, the slope of the field, the amount by which the field is changing, gives you the force due to gravity. you can think of a hillside or something like that with a slope where the distance by which the field is changing, the distance by which the sharpness of the hill tells you the force that is acting on you. Now, the answer you get for what the force is exactly the same in Laplace's view and in Newton's view, but the difference is that Laplace does not have action at a distance. Instead, the field is everywhere. So the sun affects the field nearby, and that affects the field near to that, and that affects the field near to that, all the way throughout the whole universe. In Laplace's version of gravity, there's no action at a distance. There's a field that is everywhere, even though you don't see it, and that is what gives rise to the force of gravity.
Even though you don't see it, can you measure it? I mean, well, so is it real or is it fake? I mean, is it just what is it? What's the can you put it under a microscope and tell me what it is? I don't know who this guy is. I've never seen him before in my life.
Before Einstein,
but he has good hair, just gray hair. I mean, that is one thick fur.
Physicists thought of gravity simply as a force.
So, Dan Hooper, Fermi National Accelerator Laboratory, University of Chicago. So he works with Don Lincoln.
Tracks massive objects toward one another. And in a sense, this is correct. Gravity does pull us downward and toward the Earth, and gravity keeps the Earth in its orbit by pulling it toward the sun. But this view of gravity, the Newtonian view, fails to recognize the greater significance of the phenomenon we call gravity.
That's not Newton's view, because you can show that according to Newton, light is attracted. Massless objects are attracted to massive objects. So that's not true.
What Einstein had discovered is that gravity is not merely a force, but is instead the very manifestation of the shape or geometry of space and time.
That's nonsense. It's just a way to look at gravity. It's not gravity, in my opinion.
According to Einstein, the presence of mass and other energy changes the geometry of the surrounding space and time, curving or warping it.
Changing the geometry doesn't change the universe. The geometry is just a description. You can use geometry to describe. Geometry doesn't change anything. Like, I can use geometry to analyze things, but that's not about the physical reality. So the very sentence doesn't make any sense, what he just said. I got a message. Let me see what the message says. Okay. All right.
And this curving or warping causes objects to move through space differently than they would have otherwise. When an object moves through space far away from any massive bodies and without being pulled or pushed by any forces, it simply moves forward in a straight line. Well, according to Einstein, when the Earth moves in its orbit around the sun, it too is moving in a straight line. The presence
That's just a reinterpretation.
The sun has reshaped the geometry of the solar system, bending space and transforming the Earth's trajectory. Gravity isn't a force at all, according to Einstein. It's geometry, which is a consequence of mass and energy.
That's ridiculous. I can feel a force pushing on my tushy right now. There is a force. Something is pulling me down and the chair is pushing me up. To tell me that that is not a force is ludicrous. That's ridiculous.
By explaining gravity in terms of geometry, Einstein overturned hundreds of years of established physics. Furthermore, his theory was not only profoundly
He didn't explain, he just described.
creative and mathematically elegant, it is also right. By this I mean that the predictions of this theory agree extremely well.
It's not a theory. Making predictions does not make something a theory.
With any number of observations of it.
Einstein does not have a theory of gravity.
Shortly after he completed his general theory of relativity in 1915, Einstein reached the conclusion that moving objects could, under certain circumstances, create ripples or vibrations in the very fabric of space and time. These rippling waves carry energy, and they propagate through space at the speed of light. At some level, this isn't too surprising that Einstein's field equations allow for the formation and propagation of gravitational waves. As a point of comparison, consider the equations that physicists use to describe the phenomena of electricity and magnetism. These are known as Maxwell's equations. One of the solutions of Maxwell's equations is a combination of an oscillating electric and an oscillating magnetic field. Together, these time-varying electric and magnetic fields move through space at the speed of light. In fact, this combination of oscillating electric and magnetic fields is nothing more than the thing that we actually call light. Light is itself an electromagnetic wave. In close analogy to this, Einstein's field equations have solutions which correspond to a propagating wave of oscillating curvature of space-time. These gravitational waves travel through space at the same speed as light, and they require no medium other than that of space and time itself. Initially, most physicists thought that gravitational waves were probably real, although they knew that they'd be very difficult to detect or study. But gradually, attitudes toward gravitational waves began to shift towards skepticism and even disbelief. For example, in 1922, the famous physicist and astronomer Arthur Eddington wrote a paper in which he argued against the existence of gravitational waves, arguing that the solutions to the field equations were mere mathematical artifacts and that they didn't have any self-consistent physical meaning. When Einstein made his first calculations involving gravitational waves back in 1916, he had used a common method of approximation known as perturbation theory. In the 1930s, he became interested once again in this kind of phenomena, but this time he was determined to avoid the use of any approximations. Instead, Einstein wanted to find exact gravitational wave solutions to his field equations. This led Einstein to reach a very different conclusion than the one he had reached back in 1916. After taking all the details of the math into account, Einstein became convinced that nothing like a stable propagating gravitational wave could really exist. Instead, he thought that gravitational waves were just a mathematical artifact that was somehow connected to the approximations that he had made in the earlier versions of his calculations. He now thought that any gravitational waves would instantly collapse. Such a failed wave couldn't possibly carry any energy, and it wouldn't have any...
Einstein was wrong about many things, but for some reason, when you talk to people and you say Einstein was wrong, they want to kill you. How dare you say Einstein was wrong?
Yeah, he has
Measurable
this kind of cult of personality that's been built up around him. He's kind of a rock star.
Yeah.
About all of this, we now know that Einstein was simply wrong.
In February of 2016,
I don't know who she is. Why does she cut her hair so short?
an international group of scientists.
Like she probably could be beautiful if she just had long hair. Well, let's see. Proof of
I blame
gravitational wave.
feminism. That's yeah.
I don't think she's a feminist.
I'm just kidding. I'm just joking.
Oh. Anyway, so I don't know what she is. If she's a professor, I wouldn't know. But she's probably a professor, yeah.
Announced one of the most exciting discoveries ever seen in astrophysics. After months of analysis, they had reached a remarkable conclusion. 5 months earlier, 2 of the world's most sensitive physics experiments in eastern Washington state and southeast Louisiana had detected gravitational waves. Both sites had picked up the fleeting but unmistakable signal of 2 black holes, 29 and 36 times the mass of our sun, colliding and merging 1.4 billion light years away. The cataclysmic event had set off ripples in the fabric of space-time, traveling at the speed of light and arriving at Earth on the morning of September 14th, 2015. Coincidentally, the discovery came 100 years after the theory of general relativity was published, when Einstein himself predicted the phenomenon, but also despaired of ever detecting it. His theory had demonstrated that gravitational waves should exist, but it also revealed that they would be absurdly minute, seemingly imperceptible perturbations in the fabric of space-time that would surely be impossible to measure with any human-made machine. A century later, decades of effort from an enormous team of scientists and engineers would make the impossible happen. Since that first announcement, gravitational wave astronomy has evolved from groundbreaking to almost commonplace. New detections, once closely guarded secrets, are
Okay. There's nothing interesting. They're not going to say anything interesting to me.
What was the name of that place? Was it LIGO? Or
LIGO.
Yeah.
Yeah, the I stands for interferometer, so it's
Oh, yeah.
something interferometer, gravitational observatory, light, not light, laser. Yeah, it's laser.
Oh,
Laser
yeah.
interferometer gravitational observatory. Yeah. Okay, so we did the bucket. I don't care about the glabby aliens. I don't care about glabby aliens. Okay. What else do you want to do? Let's go back to YouTube. Let's see if there's any news. Tensors. SpaceX. When? This is the flight. Watch SpaceX try to catch a rocket from space. IFT5. What is IFT? Test flight? Flight test? International?
No idea. I was gonna
IFT.
say, did you see the Tesla live stream on Twitter that was yesterday or the other day?
No, I didn't see it.
They rolled out robo taxis or something like that. They said they're gonna have robo taxis.
That's good. Do you own Tesla?
No,
Why not?
just overhyped. I just don't like it.
Wait,
It's like a
why?
bunch of other issues. I just don't want to invest in Tesla. I don't really invest anyway, but I just want to invest. It's really like a hyped up stock. It's not the real value of the company, if you know what I mean.
No, I don't know what you mean. A lot of people say that, but
You
so
have
what
to
if they?
actually sell cars and produce that amount of money, right?
Are you kidding? Like everywhere you go, the most abundant car on the planet is a Tesla. You haven't noticed
It doesn't
that?
matter that it's the most abundant. They have
Wait.
to actually sell the number of cars, right? Like
It's like if you look on the streets, whatever is the most popular car that shows up more than any other car, by far it's a Tesla.
I don't know what
There's
relevance that has to what I said, right? That doesn't mean
What?
that they're not hyped. Just because
I
something is
don't know what it
popular
means.
doesn't mean
I don't know what
that
it
it's
means.
not overblown.
I don't know
Like
what that
the
means.
price of the company's shares
I
are
don't know what that
higher
means.
than the profits that are produced
I
by the
don't.
company.
That doesn't have a sign. That is like what's a scientific definition of the words you just said? Like, can you say it scientifically? Is there a?
If what
Can you
scientific
measure?
the formula for measuring the value of a company, right?
Okay.
Based on
Okay. So
their revenue.
none. I mean, at the end of the day, like, what's the scientific definition of hype? Do you have a scientific definition for hype?
It's just there's a.
So if I told you, here's person X, he owns $1,000 in Tesla stocks.
Okay.
Would you say he's hyping Tesla? because he
Not
owns.
necessarily. I mean, it's okay to own things.
But that is what you're saying. That
No.
is literally what you're saying. So if he's not necessarily hyping, then who is? Somebody has to necessarily be hyping. Who's that
Yes.
person?
Well, there's not just one person. Well, Elon is one of those people, but there's other people.
Okay, what the person I just told you about, that's Elon. Why would he be hyping? So
that
anyone
he can
who,
get more government funding and more investment to do more things.
but that's true for anyone. That's
I
symmetry.
didn't say that it wasn't. It's not true for anyone. Not
Yes, you
everybody
are.
has the same.
No. Look, there's
a
this
personality around them that Elon has.
that you can make a symmetrical claim about the rest of the universe like that. So why is Tesla different or Elon different than the rest of the universe? Why are you
I
not
don't know what
making
you're
that?
referring to.
You just said, I asked you, here is a person, theoretical person X, who owns $1,000 worth of Tesla stocks. Would you
That's
say
fine.
that he?
I didn't say that he was hyping the stock.
Then
The
who
individual
is? Then who
the
is
people who are hyping
hyping?
it are hyping it. Like, I don't know what you
Yeah,
mean. Like,
okay. Who is that person? I just told you
I
a
named
theoretical.
Elon and a few other people. Like, I don't know.
Okay, so you're saying that anyone who owns a stock
No, I didn't say
has.
that.
Hold on, wait. No, I'll help you. I'll steelman you. You're saying anyone who owns a stock in Tesla has a vested interest in hyping Tesla stock because he wants the price to go up, right?
Maybe, sure.
No.
Yeah, sure.
I'm helping you. I don't know how else to argue for your side. Anyone who owns Tesla stocks has a vested interest to otherwise why? Okay, if
I don't know what that has to do with my claim, right? About the value of the company.
I'm trying.
And
Look,
people's perceived value of the company, right? Like, if people perceive that the value is $1,000 a share, and the company isn't taking in that kind of revenue for it to.
Okay. I'm not looking. I'm not looking at any number. I'm looking at an abstract stock, an abstract piece of paper, a stock. I'm looking at that says Tesla on it. And somebody, I tell you, owns it. Mr. X, we're not going to disclose his name. He owns this stock or 1,000 stocks or $1,000 of stocks in Tesla. He owns it, right? You would agree that he has a vested interest to hype Tesla's stock that he owns. Of course, he wants to say it's worth much more so he can sell it for more, right? That is when you say, look, I'm just giving you the quantum mechanical definition of what you said. You said it's hyped. So I'm breaking it down to the micro, to the quantum mechanical definition. This is, in order for you to be correct, this is what has to be. This person who owns Tesla stock has a vested interest in his heart, in his guts. He wants to hype it because he wants to sell it for more than he bought it. Obviously. If that's not what you're saying, then I have no
some of
idea
them
what
might
you're
get
saying.
dividends, maybe, but yeah.
How is the dividend going to change? The dividend is the profits that the company has. How is that going to change? In order for there to be profit, okay, fine. I agree. He wants to hype. That's not the stock. He wants to hype Tesla, the car, in order for there to be more sales because he gets dividends from the sales. So of course he wants to hype the Tesla car. Right? That is right. In order for your hype theory, right? You have a theory that Tesla's stock is overhyped, right? Or the Tesla's car / stocks are overhyped or hyped. They're not the real, right? This is what all the experts, quote unquote, are saying. It's not the real value. It's above the real value, right?
Sure.
No, sure. I'm trying. Look, I'm making your case. I'm trying to understand your position. Of course, your position is utter nonsense. It's a talking point that I've heard since the beginning of time. That there is so-called financial bubbles. There's stocks that are being hyped. No, that's fake. That doesn't exist. That's a conspiracy. That is literally a conspiracy theory. There's no
listen,
such
if you
thing.
go on YouTube and people are making claims,
That's a
YouTube
conspiracy.
channels.
Those are conspiracy.
They don't have to be in a formal conspiracy with one another. You just believe in a common idea.
Those are all. If you believe in a common idea, you all believe in a conspiracy theory that there is somebody hyping something. I'm offering you. I'm breaking it down to you for you. So it's.
There's a difference between someone conspiring for something to happen and something.
Then what do you mean?
People
what do you
acting
mean?
and just
Then
an
who is?
effect occurring.
Then who is hyping? Who is? So what you're saying is. It's organic.
People who are excited about the company.
Then that's organic. What do you want? That's
I don't know
not.
what you mean by organic.
That's not.
Like if he
that's not
promises
hyping.
to deliver solar tiles and then doesn't. Or he promises.
No. So look, I'm trying to steelman your hype. Now you changed it to legitimate excitement. That's not hype. That's legitimate excitement.
But that excitement has to have some grounding in reality, right? That's the issue.
Look, I don't know what to tell you. I'm looking at the price. Let's say everyone is excited. I don't buy the excitement. I'm not as excited as they are, but they seem to be excited. They're willing to pay, right? What do you want? What can I complain that they are excited about a car, about Elon, about the company? They're excited.
It's okay. It's okay to be
If they're and now you're claiming, well, it's unrealistic. Okay, they disagree with you. You know, everybody has.
Wait. They're saying they're investing in the company, and I'm saying it's unrealistic because, like there's a claim made, and then the claim.
It's fine, and that's why and that's why you're not. That's fine. That's why you're not invested. Right. They disagree with you. You know, you don't agree with everyone on everything. I would think, right? Because right, you're right. So some people disagree with you over the value of a stock. Okay, would you say that's a hyped stock, or would you say that is the market value? I would say by definition. By definition, any stock price is by definition its market value. By definition, you can never have a hyped stock. By definition. By definition, you can never have a stock bubble. By definition.
Okay.
It's your opinion. It's fine. That's why you're not invested. Because your opinion is that it's hyped, that it's not worth it. Fantastic. Then don't buy it. But that's not hype. It's your opinion. That's not hype.
I mean, what else would it be? I mean, everything is going to be someone's opinion. I mean, like, well,
exactly. Exactly. So you can say about everything that is overpriced is hype. Fine. That's fine. But what's your scientific measure that it's a hype? How do you measure scientifically? Your opinion is low. Their opinion is high. That's a disagreement. But right, you're saying, should I buy the stock? Right? Is it going to pop? Is it a bubble that's going to pop? So I keep hearing since the beginning of
objective
Tesla,
measurement is going to be the revenue that comes through the company.
No,
like
right.
What other objective measurement are they going to have?
Fine. So, but you think it's a bubble? You think it's going to pop? Right? That's your claim. Why are you not buying? Because you think that it's going to drop any second.
It already dropped before. I remember when it was at a peak and then it dropped by like 50%.
Fine, but it didn't drop to zero. It didn't drop.
It would drop to zero. Like, the company's not worthless.
That's a bubble. Anyway,
no, a bubble
look. Okay. Prices go up and down. To call it a hype, to call it a hysteria, to call it names. That's just name calling. That's not scientific.
Okay.
No, it's
if you say so.
No, it's
that's
not
just
if
your
I say
opinion,
it's not if I say,
man. Okay.
It's not if I say. It's like anytime you buy something, I would say you're hyping it. It's like, or every time you buy food, no, you're overexcited about
it.
You're making
me hungry. You're making me hungry with all this talk.
I'm hungry. Anyway, no, it's like people keep telling me since the beginning of time, oh, Tesla is a bubble, it's gonna pop. Okay. Bitcoin is a bubble, it's gonna pop. Okay. Real estate is a bubble, it's gonna pop. Okay. Yeah, I keep hearing all these bubbles exist and they're gonna pop, and they never pop. And whenever they do pop, and I look at it, they never popped. It was hype around as if they popped. Like prices sometimes drop. Housing prices dropped in 2008 by 20% on average. Wow, a bubble. 20% drop. A housing bubble. 20% drop. When it was rising by 100%, that's normal. Nobody complained. But when it dropped by 20%, it's a bubble. It's a bubble. And then it rose. Since then, the prices are much higher. Now it's not a bubble for some reason. So look, people keep selling this point that there is bubbles because they're idiots. Because people think they sound like experts when they prophesize that loom and gloom. There's like the that's what I think it is. It's like people like it's easy to be a doom prophet. It's just easy. They're always warning. Like I listen to all these financial advisors, always warning about the next financial crash, and you keep listening to them for years. They're predicting the around the corner next financial crash. Years. At one point there's going to be a financial crash for some reason or another, and they're going to say, "I warned you. I was correct. I'm a genius. I'm a prophet." And everybody's going to celebrate them because they were warning for years. They were warning, and they saw it for years, and they're idiots. Everybody's an idiot. Things happen for one reason or another. For now, there's no reason to suspect Tesla's going to drop, housing prices are going to drop. There's no reason. If there was, then the prices would already go down. Because
the price did go down on Tesla yesterday when they displayed the robo taxis. It dropped by 9%.
So what? So what? Prices
wouldn't go down.
Prices
But there's no reason for it to go down.
No, if there is a reason, fine. Prices go up and down all the time for many things. So prices going up and down all the time, that makes everything. So everything is a bubble. Everything is a bubble.
I didn't say anything about a bubble. You said the bubble.
No, but so what's your scientific definition of a bubble?
Well, I didn't say anything about a bubble. You're the one who said
What's your
thing about a
scientific
bubble. I'm just saying
definition
the price is inflated.
What's your scientific definition of hype? How do you define hype? This stock, that stock, it's hyped, it's overhyped.
Where there's people making claims and they're not able to back up those claims. Right? That's the issue, right?
Like Elon Musk?
Like a bunch of people.
What do you mean? Well, let's talk about Tesla. So you think Tesla is overpriced? You think Tesla is overpriced?
Well, it depends on how
yes or no. It's so simple.
I just said
do you think the price is
going
to drop?
Quite high.
Do you think
I don't know that it will drop. I mean, if they produce a good product, it might go up.
What do you mean the price is high? I don't know what that means scientifically.
What do you mean? It's more than I would pay for the stock. That's what it means.
I don't know what it means.
If
so
I bought the stock,
is it going to drop? Is it going to drop? Is the price? Is Tesla? What are you doing?
I'm making a cup of tea. I'm getting a spoon out of the drawer. What's the issue?
I get
you really invested. You got your savings in Tesla. Is that what's happening?
No, it's nothing to do with it.
I believe you. I believe you.
No, it's about all these so-called experts. They keep predicting this collapse, that collapse. The U.S.
I didn't say there was a collapse or anything.
Not
I just
you.
Said
not
sure.
you. There's these people. They keep predicting the next collapse for years and years.
God. Peter Schiff and those guys do that, and it really annoys me that those guys do annoy me.
I know, but
it's
not
like
just
invest in gold.
But it's not just Peter. But it's not just Peter Schiff. There's so many of them. This guy, Yaron Brook, he is a professor of finance. He's always saying the crash is around the corner. He doesn't talk like Peter Schiff, but every time he talks about it,
you're wrong,
he says it's around the corner. He
keeps saying he's a libertarian and he's got.
It doesn't matter. It doesn't matter. All the financial advisors that I listen to, all of them, they're all predicting some crash around the corner. There's always a crash around the corner. But they never say why. They never give you the mechanical explanation why. What's going to change? Right? Something needs to change.
Well, sometimes they do that. Like, I've definitely seen people do that.
They never do it. Never.
What do you mean?
look, I listen to all these guys all the time. He has never given a mechanical reason why the West is going to collapse. Wait 1 second. So I have a message on Discord. Somebody's saying something about me. 1 second.
Just saying your physics is too powerful.
My is too powerful, yeah. I don't see me mentioned. How do you know if I'm mentioned anywhere?
You can do a search, and you can search for mentions a particular person.
Let me see. Like my iPhone says that Navi. Oh, on my server. This is the dumbest thing. Like when there's things on my server, I never know. There it is on general. Even though I don't want, like, my server should not be muted.
You can go into settings and unmute it.
It's not. Everything
Oh,
is
okay. Maybe you
completely.
have Discord notifications turned off.
Everything is
your
turned
mobile phone.
on. Everything is
fair
turned
enough.
on. There's no suppression. All messages.
There are little ninjas who are sneaking into your phone, stealing your notification. They're notification ninjas.
There's no suppress. There's no
The
mute.
ninjas are suppressing
Mobile
you.
push.
They
You know,
are.
maybe I'll do only mention. I don't know. Maybe this room is suppressed. Anyway,
don't
what is
know.
he saying? He's saying, Tovarish Lu. Tovarish.
I don't know what that means.
Crew is one family. It's communism. Tovarish is like comrade in
Okay.
Romania. Like one morning they invented this new word, Tovarish.
Oh, okay.
Here is the Aaron Brooks server. Oh Jesus! There's never any activity on it.
Oh, they changed his Wikipedia page. He used to be. They used to say he was pro-torture and stuff like that, but the editors changed it so it doesn't say his controversial positions or something.
No, I think he's
they
pro
edited.
torture. Anyway, right now I'm really hungry. Do you have a PhD? No, you don't have a PhD.
No, I don't have a PhD.
Yeah. Oh my god, you're so funny.
Why would I have a PhD?
Okay, let's see when exactly is the launch. So scheduled
Is there even
for
a launch, or is it like a fake video? Is somebody fake videos of the launch?
No, it's
There's an actual launch. Cool.
It's an actual launch. It's tomorrow morning, I guess.
Mm-hmm. Cool. Are they on schedule with the whole thing with NASA or whatever? They got some government contract.
Apparently, they wouldn't announce, like, until today. Every time they announced of a flight, they had permission and they flew. So they probably got permission.
Yeah,
I think
Thunderfoot is always hitting on SpaceX.
I think Kamala actually made phone calls. Like,
yeah?
I think Kamala, yeah. I would not be extremely surprised if we found out Kamala made some phone calls.
Elon says
Like,
he's totally fucked if Kamala wins.
what?
Elon said
What?
he's fucked if Kamala wins or something like that. Like he's going to jail.
Elon said it? Yeah, she's going to destroy him, of course.
Why would
She's
she
going to
destroy
destroy, but it's fine. She's going to destroy the planet. I mean, we're not going to have a planet if she wins.
Of course.
Pretty much.
She has the planetary bombs that's going to blow everything up. The Death Star.
she's going to look. I mean, she's
the moon was actually a Death Star, and
look, things are gonna. I mean, I wish she were like some warmonger, but she's not. I mean, you know, she's probably not gonna do anything. She's not gonna help Ukraine. She's gonna hurt Israel and
probably,
everything.
yeah.
She's gonna destabilize. She's gonna help Iran get an atomic bomb.
Yeah. Do you hear about the Irish are having beef with Israel right now? Like, oh my god, because Israel is going into Lebanon to fight Hezbollah, and
wait, Navi's with us. Navi, if you want to join us, you can join my my StreamYard.
Okay.
And then we can stream together. Do you have the link to the StreamYard? But I think I'm gonna go soon. I'm kind of starving. I'm kind of dying.
You're just hearing me cooking stuff. You're hearing me like
no, it's nothing to do with
kitchen
it.
things and...
No, I'm actually starving.
You know who's really starving? People in Palestine. Okay, think of those people. Okay.
Of course they are. Yeah.
Yeah, all the food trucks
What's
going in
the
and out of there.
whiteboard?
What's the whiteboard? We did an analysis of the bucket thought experiment. You can ignore it. I'm leaving the whiteboard.
Bucket?
But I think I'm gonna go eats. I'm gonna go eats me some foods.
Okay.
So tomorrow morning. I don't know. Is it tomorrow morning? Or is it tomorrow night?
Tomorrow is gonna be morning.
No, the launch IFT5. Is it? What time is it scheduled for?
I don't know. Who knows? What are they? They're just doing a test, or was it?
No, they're flying.
Flying what? Where?
They're gonna
go pee.
They're gonna try and catch the booster. Are you kidding? It's gonna be awesome.
Cool.
You can stream that.
Yeah.
You message me when that happens.
I'll try.
Yes.
I don't know if I'll be if I'm gonna be up.
Is this one gonna explode?
I don't think it's. I think it's gonna. It's because they said that the last booster landed within half an inch of where they planned for it to land, in the middle of the sea. But within half an inch or half a centimeter, like a tenth of an inch, like it
Half a centimeter is 5 millimeters. That's impossible. Half an inch is like twice that amount.
Yeah, I'm saying I don't remember which it is. Let me see. How close to the mark?
Yeah, but what's your scientific definition of half an inch and half a centimeter?
GPS.
What's your quantum mechanics?
That's impossible to even measure.
IFT for. I'm telling you what I heard. So that's what I heard.
I don't know. I think it's high.
Yeah, you probably misheard.
Maybe. Here, I'll show you. I heard it from this guy, from Tim Dodd. Wait a minute. Where's Tim Dodd? The Every Morning Astronaut. Tim Dodge.
I think you should change your profile pic.
To what?
I see things that this company has done, like.
You don't know?
Can you see my profile pic? You can see where it says spin an astronaut. Can you see that? You know what that is?
It calls upon 33 of the. SpaceX is preparing to do something truly absurd. Of all the crazy things that this company has done, like launching a Tesla Roadster past Mars, catching a massive fairing from the edge of space with a boat and a giant
You're leaving?
and reusing a Falcon 9 booster. This might be the most.
All right, man. See you later.
SpaceX is attempting to catch Starship Super Heavy out of the sky after it's flown to space with a giant robotic tower. And although this might sound downright impossible and maybe pretty stupid, well, importantly, why? Why is space? I can't predict the future, so I can't tell you for attempt. That tends to be the SpaceX. Because I know this is a very short overview of this process. If you want a more detailed explanation, ship is of course the largest and most powerful leave the ground. The Starship full stack is over 5,000 engines ever built to get the job done, and of course these should be about 75 meganewtons of thrust. And once the engine is about 70 kilometers and having traveled over 60 kilometers down range already, before commanding most of its engines to shut down. But interestingly, the booster leaves 3 engines running, so the rocket can do its running in order to increase performance and make starting 3 engines that are running, the warm gas bulge thrusters, and brake forms a boost back burn for 50 feet. The booster and pad will have conducted thousands of distinct health checks during the first 3.5 minutes to target the launch pad for the tower catch attempt. Now, if the manual command isn't sent, or if the computers see any issue with either the booster or the launch tower, the booster will default to a trajectory that will have it splash down short of the launch pad in the Gulf of Mexico, similar to the prior missions. This call has to be made prior to boost back burn shutdown. After jettisoning the hot staging ring that gave the exhaust gas of the upper, eventually on upcoming boosters, we shouldn't see that anymore. As the atmosphere thickens, the booster uses it to actually provide the torque required to control the fins. And the booster for a slightly shorter boost back burn, which launch pad just by flying it and gliding it through the atmosphere. So the booster continues to decelerate due to the atmospheric super heavy booster doesn't do an entry burn at all. It stands instead of using it to slow down on descent. Right about when the booster is going through the transonic region, so and relies on the center 3 engines to precisely control it for the remaining portion of the landing burn. This offers a big advantage over a single engine landing burn like the Falcon 9, assistance from the grid fins and cold gas thrusters to control roll. 3 engines on the super heavy booster also can throttle down low enough to allow the booster more thrust than the rocket weighs when it's nearly empty. So the Falcon 9 has to time its landing burn perfectly. But having the ability to hover and precisely control the booster with just the engines is a huge advantage when it comes to this last important step, which is landing the booster within the arms of the launch tower, which is also known as Mechazilla. You may have noticed that I said land the booster on the tower and not have the tower catch, just that the booster is aiming for GPS targets and the arms will be at that point at the right time. Perhaps the arms do have some additional tracking and a way to adjust for some offsets, but we don't think that the arms will move up or down at all during the catch.
But I guess we'll just have to see. As the booster closes in on the tower, it'll shimmy over and get within the reach of the arms. It'll slow down to nearly a hover as the arms are closing in on the booster, so the booster can land on these catch and lift points. The arms do have a small amount of padding along the landing rails to reduce potential damage to the booster. The arms will basically slap against the booster, and hopefully that ensures the catch points come in contact with the rails. And again, if you need a more detailed explanation on landing directly over top of the launch mount, and the pad will actually re-engage the water deluge system, the same one that it used during takeoff. To be honest, I'm a bit surprised at this, but I suppose why not do it if you can, and all of the mass of the nearly empty booster will be supported by the launch tower arms. And this whole catch thing is something that we've seen SpaceX test in various ways. Between slap tests, where they took the arms and let them slap a test tank over and over and over, and weight simulator tests. They seem to have enough confidence to be able to put all the pieces together. Oh, and meanwhile, while all this is happening, the Starship upper stage will be continuing in extreme re-entry conditions. Well, speaking of the Starship upper stage, once they can confidently bring it back from orbit a few times and nail a pinpoint landing perfectly, they'll also hopefully begin working on bringing Starship back to the launch tower to be caught as well. So that's the exact plan on how this will all work. But what about perhaps the biggest question? Why? Well, before we so you can compare how different launch was covered in the center and bias and test or been invaluable to me for enhancing mind news unlimited access. Now back to why. Why landings and also decrease the turnaround time legs. You can kind of think of it as having relatively easy. I mean, after all, they can already control the Falcon 9 booster to be within a meter of accuracy over and over almost every single launch. And the Super Heavy booster should actually have better fine control compared to the Falcon 9 booster. In fact, former NASA Associate Administrator for Human Exploration and Operations and current Vice President of Build and Flight Reliability at SpaceX, Bill Gerstenmaier, said that Flight 4's booster landing was within half a centimeter accuracy.
Yeah, half a centimeter. 5 millimeters.
Nice.
Yeah, that's what I thought.
Nice.
Yeah. I don't like being questioned. I don't like my authority questioned.
So what are you going to do now? You're going to invest in SpaceX?
There's no way to invest in SpaceX. If there was, a lot of people would invest in SpaceX. I don't know why Elon doesn't want SpaceX investments.
You can try and buy shares privately, can you? Surely somebody owns private shares and might be willing to sell them to you.
Yeah, but I don't think anybody. I mean, how I don't even know how to go about that. I don't think. Well, it's not available, so that's the end of that.
Kidnap somebody and force them to sell you the shares. I mean, that's just the only logical.
This is interesting. This he says tensor calculus for physics majors, preliminary vector stuff part 1. Oh, this is just part 1. Jesus Christ. 52 minutes part 1. Tensor calculus.
On head over there. The good old days.
She's funny.
It's like talking about Hamas. Hell world. Late stage capitalism.
Late stage capitalism. Okay. Maybe I'll do just a little bit of what do you call it? Calculus, tensor calculus.
Okay. I guess I might let you go. I'd leave you to your tensor calculus. Yeah.
Putting out all the systems necessary to make that possible. Critical systems for propulsion, life support, and the elevator that you see here.
What happens if I leave my browser? Sorry, what? Look at what?
This is live from the launch pad.
Mock-up suits that are used to demonstrate the range of mobility that
live flight 5 countdown. They're going to be streaming.
And figure out the layout of the elevator.
Yeah, they always streaming. Yeah.
Development work.
No, but they're going to be streaming from now until then. I guess because they're saying this is the live flight, so it's live.
Surface expedition since
right.
1972.
So they're just going to talk. They're just going to replay the past 5 flights. I guess one after the other.
There's so much to look forward to, and that's why we have a countdown, is to allow us to find those issues prior to liftoff. So all of that being said, our teams learned a lot over the last 48 hours, and we are ready to give it another go. As many of you know, Starship is the latest and largest vehicle developed.
Tim Pool, demon phase disorder possibly caused by solar, weather, and magnetic fields. He is becoming such a conspiracy theorist. Jesus Christ.
Now might not be the same original formula for the glass that it was when the military was using it, and it freaked out the soldiers so bad they're like, we can't put these on anymore. Yo, look at this story from NBC.
He's always just inviting conspiracy theorists.
News. Rare disorder causes man to see people's faces as demonic. The condition causes faces to appear distorted. My first thought was I woke up in a demon world. Yo, like, what if you did?
Yeah, no, you did.
Well, you didn't tell me that he literally saw people with bat-like pointed ears and stretched out faces and eyes.
You have a pill for that.
Tim, do you know when this article came out?
Don't take it.
There's
Only 65 side effects.
2024. This was right around the solar eclipse.
Oh, yeah.
If you watch the
Never
music
seen
video, it's a black hole sun.
Great.
All you see are these weird faces during this eclipse, just like that article. It's very odd.
Maybe he's very sensitive to electric.
What a waste of time.
Yeah, it's Tim Pool, is it?
I mean, I used to watch Tim Pool all the time, like, but as time
I've been working with
progresses,
Lauren Chen recently, and like at Tenet Media, and they were like funded by the Russians, and they were getting like $100,000 a video or something mental.
right? So,
Crazy.
I mean, Tim Pool is just in complete agreement with Putin, and it doesn't seem to bother him. It's like,
yeah, he was like, "We need to stop Ukraine." It's like, Jesus Christ, dude! Like, what the fuck?
yeah, Ukraine is the worst enemy of the United States.
Yeah, exactly.
Like, why would you say that?
He just keeps saying that they're like giving them billions of dollars. Like, I don't just give them cash. Like, those are like weapons and munitions and
Whatever. Even if we gave them money, so what? I mean,
yeah.
But he says anyway. No, he's yeah. He used to be normal. He's becoming more and more an extreme right winger.
Yeah.
As time progresses.
Mm-hmm. I guess there must be money in it or something. I don't know.
No, I don't think it's money. He's like, you
Well, I mean, if
know,
he was getting some serious money from Russia, I mean, it
but
sounds like
but he's not getting the money in order to support Putin. He's getting the money because he supports Putin.
sure.
So,
That's I think
so
there's a combination there. Of
he's
both
just
of
an
those.
ally. He's like Iran. Iran doesn't need to get money from Putin to be pro-Putin. They're just allies. China, North Korea, Venezuela, these are just natural allies. And Tim Pool is just a natural ally to this axis of evil, and he doesn't care.
Mhm.
You know, a lot of extreme right wingers and extreme left wingers are on this boat. They're all against it. It's like whatever will destroy the United States. Like, as long as we can destroy the United States.
True.
No, really. That's
Yeah, no,
what it's
they are.
about.
They're literally anti-America. It's crazy.
I know.
Anyway, I gotta go. I'll chat to you.
All right, man. I'll talk to you later. I gotta go too. Bye. Thanks for being with us. All right, I think we're done. I gotta go eat. Yeah, omnivore is still not available. I need to do. So, what did we do today? What did we review? We didn't end up reviewing what I wanted to review. So the title is all wrong. We watched both of these videos, but we watched a bunch of other videos. So, yeah, it doesn't matter. We didn't do what we wanted. Wait, there's no way to get out of this. Okay. All right, everyone. See you next time. I'll be back later. Bye.